Hello, hello. How is it going? Welcome back to Large Data Bank. I hope you're doing great on this day. Starting a little bit earlier today because I figured why not? We can go for longer. Gets dark, get tired, so if I start a bit earlier, then maybe we can do more. So I'm pretty pumped about that. Today, I think we're gonna jump back into doing some partial index stuff. We made a pretty good amount of progress, I think, since last time. Basically, where we're at this point is that we have most of the execution support for partial index is finished. There's still like a couple of little problems with it, but that is okay. Maybe we can fix some of them this time. Another thing that I want to do today is try to start looking at how to teach the optimizer a little bit more about how to use partial indexes, or specifically when it's appropriate to use partial indexes. And I'll give some examples of that in a little bit. But yeah, so essentially, I kind of want to have like a little to-do list thing set up on the screen. I think that would be pretty neat, but I haven't quite figured out how to do it yet. But that being said, I think what I'll do to start off with is get reacquainted with what we've got going on so far. I've written a few tests since we started this whole thing that I think would be helpful to look at. And the tests are really specifically about when you insert data into a partial index, what data do we actually write to the indexes? That's really what it's all about on the execution side of things. So why don't we go ahead and start out just by regenerating our binary here, because I think my branch is just a bit out of date. Hey, Circus Maria, thank you so much for the follow. Welcome to Large Data Bank. So we're just going to regenerate our binary here and play around a little bit with the database, with the partial indexes that we've got going so far. And after that, we can jump into seeing sort of what's wrong with the current set of implementation parts for the execution side, and then jump into the optimizer as well. I did set up a couple of chat commands. So you can actually type !project to see a little bit more about what partial indexes are about. Or you can type !CockroachDB to see about a little bit more about the database that I'm actually working on in this project. So if I go ahead and open up like a little basic shell here, basically I should be able to make a table. We'll call it users. We'll give it an integer column for ID, maybe. Yeah, we'll just do an integer column for ID, and we'll say active bool to say, is this user an active user or not? And we're gonna try to see what happens. We make a partial index on this activity flag, which is sort of one of the main use cases for these partial indexes in the first place. Whoops, right, I'm in this database that's got some sample stuff in it. So let's make a new database. Actually, you know what, let's make this, we'll actually do this in a database that persists, so I don't have to keep redoing it every time. So open up a new window here with our shell. Actually, you know what? This is going to be our shell, and this one's going to be our server. How about that? Okay, so we'll make our users table here. And we'll make our active column here. And then hopefully we should be able to say, with some of the new powers that we've added to the database, create index on ID, on users of ID. And we can add this predicate, which is what partial indexes are all about, where active is true. Hopefully this should work. Cool. So what does this mean? It means that every time we write some data to the users table, we're going to actually add an index entry to the ID index of users if the user is active, and not if it's not active. So this is actually cool because in the case where you didn't want to spend a lot of disk resources or CPU resources pointlessly indexing stuff, Users that are not active, you don't have to. So we'll try it out. And we'll actually turn on our little tracer machine so we can see what the database is doing under the hood. Set auto trace equals on comma kv. So if I go ahead and insert into users values, give it ID 0 and active true, hopefully what we'll see is an index entry getting emitted for our secondary index that's partial. And if we do it again for another user that isn't active, hopefully we won't see that entry and we can compare them with our eyes. So as you can see, this is looking like something promising is happening. Here we have this cput thing is basically saying, I'm inserting data into the primary index of users. And this initput thing is basically saying, I'm inserting this row into the secondary index of the users table. You can tell that there's two different indexes going on here because I just so happen to know that this number here means the table ID of the key that we're writing to. And this number here means the index ID of the index that we're writing to. So in this particular case, we're writing to index number 1. In this particular case, we're writing to index number 2. And down here in our other example, where we are trying to write data to an inactive user that we're not trying to index against at all, we don't see any write to that second index. We only see a write to the primary index. So that's super great. And that's basically what we want as far as inserts go. The only problem is that I know that there's something a little bit wrong. I think that also, okay, we can try it out on the delete side as well. When I delete a row from the table, we should make sure to only delete keys that we added already because of this partial index thing. And I think this will work. So let's try it out. We can say delete from users where ID equals 0. This hopefully should delete 2 keys. And you can see it does. It deletes the secondary index entry here and the primary index entry here. And if you delete something that is an index, hopefully we'll only just see a single delete. And that's exactly what we see. We just see a single delete to the primary index, since we know, given our index definition, that this particular user that had ID 1 wasn't active when we inserted it. Hey, null bitmap. Welcome back. Thank you for tuning in. Thanks for checking out the new ! project command. Very advanced stream technology. So this is all good and fine, and this is like looking pretty nice, I think. However, I know that there's a bug, which is that the update command, I think, isn't going to respect this active stuff. So let's go ahead and just let's make some new rows. Show create table users just to re-show off. Whoops. Let's turn this off for a second. Show create table users. Oh gosh, wow. Okay, so that's kind of broken too. That's exciting stuff. All right, let's drop our table and make it again. So there's definitely some things to fix here, but we're making some progress. We'll make our table, we'll make our partial index, we'll insert a user that is indexed, and then we'll insert a user that is not indexed. And then what I wanted to show off is that when I update one of these things, I'm pretty sure something bad is gonna go on. I just wanted to demonstrate that to make sure that I'm sane. If I say update users, let's do set active equals true where ID equals 1. I think this is probably going to do the wrong thing. This does the wrong thing for a different reason than I was expecting. How about this? We'll make sure that it scans the primary index. There's another missing feature that we're going to hopefully tackle today, or start to tackle today, but in the meantime, let's make sure that we're looking just at the primary index. So in this case, there's something going wrong because we're not actually adding an entry to the partial index, even though we should be. As you can see, we're updating the active bit on this particular row, And that should cause a new index entry to be written. However, we're only updating the primary index. So that's definitely busted. And I think if we go to the other direction, it might be busted in an opposite direction. So let's say set active equals false, where ID equals 1. What will happen now? It doesn't delete the old key. So I think updates are basically a little bit broken. Irfan, I think, so we're gonna have a guest, hopefully, Irfan, I hope. He's gonna come on later, but he wasn't available at the start, so I told him to ping me. We'll see if he does it. It'll be exciting. It'll be some advanced stream technology of, I'm going to open like a Google Hangout and stick it on my shared screen. So that'll be super awesome. All right, so I mean, there's basically two options. We could either try to fix the execution code, or we could start looking at how the optimizer is going to work on the read path. I'm sort of more interested in looking at how the optimizer is going to work on the read path, because I think it's just more exciting. And I think the fixing update is it's just tedious, a little bit painful. So I sort of want to look at this new thing, and I'll demonstrate that too. What happens here is that ordinarily with a partial index, if I said select star from users where ID equals 10 and active equals true, this should definitely use the partial index, because we know that the partial index is indexing every row that has active equals true. And actually, let's just explain it. Yeah. So if we explain it, we can see that that's good. It's happening. That's like sort of what we want. But unfortunately, if you set this to false, or if you don't constrain it at all, it's still going to use that same index. And that's no good, because our index is it's partial, and it doesn't contain entries where active equals false. Hey, Occupy Paul Street, thank you for joining. Welcome to Large Data Bank. I hope you smash that follow button. So we were just talking about partial indexes and what's broken about them right now. And essentially what we want to do is kind of fix this time. Thank you for following. Wow, that was instant feedback for me. Feels great. Right. And of course, if I don't specify this predicate, it's also going to use the index, which is also no good. Because the whole point is that in this particular case, the database can't know whether any given row that might have ID 10 is set to active or not. And if it's not set to active, we can't use this index, because it won't even contain the entries for the rows where active is false. So yeah, to fix this, we kind of need to think about how the optimizer in CockroachDB decides which tables to scan in the first place. And I can show you a little bit about how that works. If we can just jump into the editor here. There's this method that gets run called generate constrained scans. And essentially, let's actually jump back before we get into this. Generate index scans. I think, so essentially what happens in Cockroach when we're trying to decide which index to use is that we're going to generate all of the possible indexes that we could use for a query. Or really, we're going to generate all of the indexes that are on a table that we're trying to look at. And we're going to check each of them for usefulness, in a sense. We're going to make all, so essentially like, the idea is that any index, until we introduce partial indexes, any index on a table could theoretically satisfy a query on the table if you just like scroll through the entire thing. It won't be efficient, but you could use it to get any information in the table. So what Cockroach does is that it generates these sort of alternative plans for each of the indexes, and then it runs a cost function on them to try to figure out which is the least expensive way to get the data that we're looking for. So the thing that's different about partial indexes, though, is that we're not actually even allowed to use the partial index when it's not appropriate. So I think the first thing that we want to do here is basically teach this. There's kind of two variants of this generate index scans thing. By the way, there's kind of one that says, just give me a full table scan over the index in a sense. And there's one that says, give me a sort of slice of the index. And the reason that you could do a slice is that you have a constraint on the prefix of the index. So in our example over here, since we have this user's ID index that starts with the user ID column, we know that we can generate a so-called constrained scan given this filter and push it down into the index here. So when we search on the index here, we're just looking at the span between 10 and 11, and that's like an efficient thing. So there's one method that does that, and there's one method that generates these like full index scan things. And I think the first step that we were gonna wanna probably do is just completely ban these full index scan things for partial indexes, because I don't think that there's any time where that would be an appropriate thing. And luckily this is very easy, I think. We can just sort of say, so this is sort of, we're iterating through each of the indexes here, I think. And I think we can just basically check to see whether or not it has a partial index. It's kind of weird though. I think in this case, like we sort of have these, oh no, we do have access to the index. So basically I think we can just say, if this index is a partial index, we're just gonna like bail out. And just out of curiosity, let's just like kind of make this up real quick. I could be running like a smaller test, but just for fun, I'm not gonna do that. Why would the full scan never be appropriate? Seems like a partial index could actually index all records. I think that's true. Like theoretically, you might have an instance in which the data in your table does only satisfy the partial index predicate. So for example, you might have a table that has only active users in this example. But the thing is that the optimizer doesn't know that. And unless, I suppose if you had a partial index predicate that was like trivially true, like, you know, create index on table of column where true equals true or something like that. In that case, yeah, you could always use it. But I'm just sort of, I guess we should probably add like a thing later that says, hey, the filter that you added is sort of trivially true and just ban you from doing that. But otherwise, I don't think that it's really possible to know statically whether or not the partial index will always work. So I think at this point, hopefully, if I said, well, I'm not actually sure if I would be able to convince the database to use the secondary index without a filter. But point is, I think this is a good thing to do. And obviously, like the more tricky thing that we're gonna have to do is talk about how to modify this generate constrained scans thing. So the way this works is that it's also going to look through all the secondary indexes, and it's going to try to compare the filter to the prefix of the index. So in a sense, like the columns that come first in the index, and see if it can kind of apply the filter to that prefix, something like that. And I think what we essentially want to do here is figure out whether there's a way to turn the partial index predicate into a constraint set and turn the filters into a constraint set, and then try to see if we can sort of prove that the constraint set on the right is completely contained within the constraint set on the left. It's kind of weird. You need to know if the filter condition implies the index predicate. And I'm not sure that there's a way to do that. Yeah, I think, so I thought about it a little bit yesterday. And I think basically what you want to do is, I think it's really just like this contains operation. If you have like sort of a constraint span on the left, you might have a built-in as the index predicate. Ooh, yeah. That's actually a really good point. Well, I wonder, it's all about like what this constraint library does in the presence of built-ins. I think we could sort of ignore that for now and maybe just ban them later or something like that. I think in the case of, I would like to start with just a simple thing like we're just constraining things based on basically math, or like the operators that we know how to deal with in the constraint library. I think there's this thing called constraint builder that's very relevant here. And I think the way that this thing works is that it takes a scalar expression, which is basically what we're going to get from the filter, as well as from our partial index predicate, and it's going to turn it into this constraint set thing. And a constraint set, as far as I can tell, is basically, I mean, it says here, it's a conjunction of constraints. And I think a constraint is a disjunction of spans. So I think like our basic algorithmic task for this thing is going to be to try to write a method that says that a constraint completely contains another constraint. And I think to do that, we can sort of do it recursively in a sense. We can say a constraint set contains another constraint set recursively if all of its constraints contain all of the relevant constraints on the other side as well. And then within the constraint, I think there's a similar thing that we can do for the spans or something like that. Probably. I think there's kind of some of these set methods already implemented here, and they're just sort of missing one of them. I think there's already an implication function for constraint sets constraints. Yeah, I don't know about that. I was looking at it and I didn't see one. There's like union and stuff. Definitely not for constraint set. Maybe for constraints though. Let's find out. Constraint.go. So this constraint thing, it's got a union function, which isn't really what we want. It's got an intersection function, which I also don't really think is what we want. I guess you could like take the intersection and then mess with it, but that doesn't sound great. Now it's got to contain span. And I thought that this was going to be good, but I don't think it's enough really, right? Because a constraint can have lots of spans. And I think that you have to have like, maybe that is what we want. I don't know. Let's read it. Contains span. Contains span returns true if the constraint contains a given span or a span that contains it. I think what we really actually want here though is something that basically says it takes a constraint and it would be like implication is sort of a nice way of putting it, or containment, contains other constraint. And they're different, right? They're definitely different. If the union of the two constraints is the same as the parent constraint, then are they equal? Yeah, I think that's true. I think that if the union, if you take the union and then compare it and then they're sort of identical, I think that would be the same thing too. But yeah, I mean, I think that would work. I don't know if it would be as efficient as we want, but maybe that's like also fine just for the purposes of getting started with something. I'm not exactly sure what union does, and I'm not exactly sure how to even compare these things. I think you're getting the right idea though. I think you're getting the right idea. I mean, we could try it. We could try that out, see what happens. Union with merges the spans of the given constraint into this constraint. The columns of both constraints must be the same. I see. Well, I mean, that's a little bit of a problem though, because, I mean, maybe we should like get a concrete example going. Hey, Jarson Mar, thanks for joining the stream. What is going on? We are talking about partial indexes and constraint sets and stuff in databases. I was just gonna make an example to try to make things a little bit more obvious. Maybe we could like go into a test or something and then write a little example test that sort of tries to demonstrate what we're after here. So what the heck is going on in here is a question that I have. Test constraint set union. Test constraint set union. I guess what's happening. What is this test function? It says, oh, I see. It says it takes a CS and then it gives you back a string that's expected. And this GT20 thing is a single span constraint. What? Mildly confused about what's going on here. What is this KC1? Test key context. Okay. I'm not sure if this is going to be all that straightforward to make a test about. Is there a name for the little DSL that these constraints use, e.g. I'm not exactly sure if there's a name for this, Paul, but I think that, yeah. It's really written in terms of like, the reason that we're talking about like spans and stuff like that is sort of that in CockroachDB, everything is sort of set up to behave with range scans. And with range scans, you want to sort of represent a range of values. And we ended up sort of making this, maybe somebody else made it before CockroachDB, I really have no idea. But as a very, very quick example, if you had a table like so, and we wanted to say, select everything in the table where A is less than 10 and A is greater than 2, we're going to end up with this little constraint guy. And what this is saying is that it's sort of like the things on the left here are like a prefix. So you can imagine that this gets prepended to each of the things within the little brackets, just to make it less redundant to have this prefix on each of the things within the range. And the reason that you need the prefixes at all is that this is saying, I'm pretty sure, that we're looking at the index with ID 1. So as another quick example, if I added a column, alter table A, add column B int, and then I said create index on A of B, and then I said this same thing except select star from A where B is less than 10 and B is greater than 2, then I think we would see that something is different. A little bit confused about why there's this 2-1 here, but that's not important. Essentially, the idea is that this is the sort of span of values that we're going to be searching through inside the database. I really thought there was an implication check, but I cannot find it. Baffled. Yeah, baffled. Baffling. I'm also baffled by that, but it's okay. It's okay for sure. Yeah, so back to trying to figure out how to write this example though. I would love to understand how this GT20 thing actually, oh, I see, data.spgt20. It's just sort of this like vaguely painful way of inventing key constants because maybe we don't have like a little parser for it in this test environment. So let's see. I mean, I guess what we would really want to say is we'll make an example where we have a single key that we are going to, I think if you want to get the simplest thing, just check if the index predicate is just literally identical to one of the contexts in the select condition. Yeah, but I mean, then I don't get to run like, you know, write some constraint algorithms. And that's the dream, isn't it? It's like somebody's dream. I guess we could start there. I mean, especially because we do have to start even by inflating the partial index predicate into a opt expression thingy, which we haven't even done yet, I don't think. So yeah, I guess why don't we just like start at an entry point and we can like move on from there or something like that. So back to this generate constrained spans thing. I think down here we have this method called try constrain index. And this is the thing that's actually taking a filter and attempting to like connect it up with our index. And I think this is kind of basically the thing that we're going to edit, and we're going to sometimes return false and claim that this index is not constrainable by the filter if the predicate doesn't match up and whatnot. So that's our goal here. And we can try to figure out, don't know how to do it yet. So we start with a fast check to rule out indexes that cannot be constrained. And that sort of sounds maybe vaguely relevant, although I don't know how fast this check is going to be. So this can maybe constrain index thing. Performs 2 checks that can quickly rule out the possibility that the given index can be constrained by the specified filter. And that says, if the filter doesn't reference the first index column, then no constraint can be generated. Yeah, so that's about that prefix thing I was talking about earlier. And also, if none of the filter's constraints start with the first index column, then no constraint can be generated either. Those sound vaguely similar to me, but that's okay. What do we mean by reference here? Okay, well, let's just read what it says. If the filter involves the first index column, then the index can possibly be constrained. I see. So we have like a little set here, and we're like checking this set in a really quick and efficient way. I'm guessing we probably don't want to mess with this method because this is supposed to be like super fast or something, it seems like to me. I mean, I guess we could actually do a very similar thing though, right? We could pass in our partial index expression to this thing, and we can check to see whether any of the columns that the partial index predicate are referenced. What did I say? Any of the columns that the partial index predicate references, all of those columns do have to be touched by this thing, I'm pretty sure. The thing is, we don't yet even have our predicate thing, so maybe we should start out here and get that. So to get that, I think we have to first grab our table somehow. We do that somewhere else. This MD business. It's fun to program in the optimizer for me because like I don't really ever remember all of the little ways to access things, so I sort of have to go around searching for what other people do in nearby spots and copy it. But it works vaguely okay, especially when yeah, I have friendly people helping me. So instead of getting our index here though, what we're gonna do is we are gonna get our index, and we're also gonna get our partial index predicate thing. So I guess we can say first, we can just declare one of these things as an opt dot, I guess it's a scalar expert to be super precise. And we can say if it's a partial index, then we'll just set it. And also, well, we have to set it by doing stuff. So that's what we're gonna try to do now. Equals something. Whoops, what did I do here? This should be if. Actually, let's just, we can grab this thing into a little variable. Happy little variable, make our lives easier. And in this case, we can say, let's grab our index predicate, which I think is at this point just a string. And we have to now transform it out of its string form into a cooler, better form that's more introspectable. Pred string is equal to index partial index predicate. All right, and then there's this sort of arcane but magical way to convert this string into a opt scalar expert that I'm going to get from another similar spot of thing that turns a check expression on a table descriptor, which is also a string, into an opt expert. And I think that lives in mutation builder somewhere. So we're gonna just copy it. Hey, I have it right here because I was probably looking at this before my stream to make sure that I knew what I was gonna be able to do here. So let's just like grab all this stuff and we can mess with it. I think there's gonna be a few complications because we don't have all the same things here, but we can basically try it and see what happens. So we have to load in our parser thing, SQL parser, and we're going to, what happened to this? This should go up on top. Get our predicate string, and then we're gonna try to parse this pred string thing, dot predicate. And I think that next, so at this point we have sort of like an AST tree thing containing our predicate inside of expr. This is a tree.expr. And a tree.expr, yeah, it's sort of like a simple AST with no really extra information. The next thing that we need to do is like sort of hook it up to the sort of like information about the table that we're looking at here. Of course, for example, if you had some sort of scalar expression in our partial index predicate that says, like in our example, active equals true. We know what true is because it's a constant thing, and we know what equals is because it's just sort of like one of these operators that's like defined in the grammar somewhere. But this active thing is actually something special. It's a column reference. So what we have to do is figure out like where this column reference is pointing to. And the way that we do this over here in the mutation builder, which is like sort of earlier in the chain of things. This is sort of when the optimizer is building the, well, maybe it is sort of actually at a similar stage. Where does this stuff all happen? It happens when we're making an operator, right? And the question is like, there's this abstraction in the optimizer called a scope, and the scope has something useful, which is the current set of columns that are in scope, which is sort of exactly what we want. So the question is, how do we get one of these scopes into this thing that we're looking at, which I guess is sort of at a different part of the code. This is, it's in a transformer section, which is a bit different, I believe, than the section that we were looking at in Mutation Builder. I believe it comes later, probably. Anyway, maybe we can sort of look around to see if anybody else uses scopes in here. That would be a good thing to do. That would be a good thing to do. But I don't know if they do. I do not exactly know if they do that. What do we have in our custom funcs? Have some factories. We have some memos. Maybe, I wonder if the like memo group that we're in might have a scope. Could that be true? Well, let's try to see who else keeps a scope. Maybe that would be helpful for us. Tons of people keep scopes. Maybe what we actually have to do is sort of like keep a reference to the scope in the thing that this custom funcs guy has access to. That would be an easy way to do it, because we know we have it earlier. And at this point, what we have is we have this rel expert group thing, and we have this scan private thing. Maybe one of these could actually just store a little reference to this scope thing that we need. I don't know though. Group, what does a group have? It has all sorts of stuff that I truly don't understand. Ah, well, this is gonna be useful. Maybe. I think what this gives you is the set of things the set of columns that it needs, which I'm not actually sure if that's the same as the scope thing that we're looking for here. It probably isn't. Well, why don't we just try the super hacky thing that I was thinking of. Inside, we're gonna initialize this somewhere in the build scan area. And I'm guessing that when we're initializing this thing, we probably have the scope that we're looking for. So we could just sort of stick it in there, maybe. Where would that be? See what happens. So this is actually going to be maybe similar. When we add check constraints for table, I know that we have to do a similar thing. Aha! This is the similar thing that I was thinking of. We parse the expression for this check constraint thing from a string. And what do we do with it is that we have a table scope. What is this table scope? Scope is makeable with a reference to builder. What does this do actually? What does this do actually? Maybe we can just sort of pull one out of thin air. Because it looks like all you need to do is pass this builder thing. And what do we use builder for inside of the scope? That's another question I have. In this case, I see you need like this semi-context thing. Look at how we use the computed calls thing for generating spans. That's a good idea. That seems like a little bit more similar to check expressions in this case. So in that case, I think what we're talking about is we make these sort of optional, no. No, wait, this is not where we're trying to go at. Where is this generate constraint scans things at? Computed call filters. It takes in some explicit filters and some optional filters. We've just check constraint filters. What do we do here? I see. So actually what happens here is that we pre-populate the tab meta with the constraints as scalar exprs, which seems like way more cool than keeping it as a string for so long. So that seems like a great idea to copy. That seems like a really good idea to copy. Let's copy it. Let us copy it. Add constraint. Add constraint. Who calls this thing? Add check constraints for table. Oh yeah. We should definitely do this. We should really do this. Ah, it's perfect. Build scan. This is, it's called building on the shoulders of giants. It's great. I don't think that, yeah, without the giants, I would really be in big, big trouble. Yes, okay, so let's do this. Well, we're gonna make a new thing. We're gonna call it Bonk B Builder. We'll call it add partial index predicates for table. And it'll take a tab meta. Maybe it wants to take an index meta. Let's just give it a tab meta. And then we can maybe just iterate or something like that. And so what we do, get rid of this thing. What we want to do is, yeah, this makes much more sense. I was literally staring at the answer. Table scope, we make our table scope because we have our builder. Then we say, for each of our indexes, I is equal to 0, I is less than tab dot partial, whoops, meta tab. Oh wait, I see. Tab is equal to meta dot table. So we've got our table thing. And I think inside of our table, we actually have a number of partial indexes that we have. For each of these things, we're going to say, get me the, oh wait, we still have to like pointlessly look through all of them, I think. That's kind of gross. Like I sort of wanted to fix this, but I didn't get around to it yet. So we'll just do, I guess we can just quit early though, if we don't have any partial index predicates. So we can say if tab dot partial index equals 0, we can just get out of here. Right. And then we're gonna say for each of our indexes, I is less than tab dot index count, I plus plus. We're gonna say, give me our index, right? And then we're gonna say if index dot partial index predicate is not equal to empty string, I think. or is there like an is partial? Yes. I guess we need to figure out a little spot to cache this thing. And the way that we're doing it up here is we say add computed call. Is that what we want to do? Add partial index predicate. I think we probably want to add it like to the index. So we'll say index dot set partial or something. Func oi opt index. We'll call it like set partial index expr or something. I don't really love that, but whatever. I think it's okay. Then we also, I think, have to add this to the interface that it's a part of. So we're gonna say add partial index or set partial index predicate. I mean, this is like kind of gross the way I've done it, because like this is saying that I guess ideally this method would return the opt version of it and not the cat version of it, because this thing is just a string and we really want to like upgrade the representation to be better. I wonder what they do for the same problem for computed columns, because over here I guess we have to say if it's computed. Oh, I see. That's on the column, and this thing is like on the, I guess what's the access pattern that we're going to use for this thing later? That's a question. The access pattern is that over here in custom funcs, we're going to be looking. We're going to be looking to, we want the index right here, basically. And we have an index, and the index is a, yeah, I mean, we should just like cache it on this thing and just like move on to their lives. That's fine. We'll say set partial index expr for now. Oops. Set partial index expr. And it's going to take an opt.scalar expr. Set partial index expr sets the optimizer representation of the partial index predicate on this index. Oh, this needs to be a scalar expr. Doesn't like me. Okay. And I think we need to add this to our test catalog implementation as well. Test index. Test index? Test cat. I think this thing also has some sort of index representation. And we need to add this as well to it. So we'll say ti index set partial index expr. Are we allowed to import opt here? Ooh. I don't know if we're allowed to import opt here. That could introduce a big problem into this plan. That could really introduce an annoying problem. So wait a minute. Wait a minute. I think that this should be fine, because like literally we do the same thing. Scalar is a opt.scalar expr, and this thing is a, oh, it's part of table meta. This is why everything is weird. We're not actually going to change the catalog. We have to add this. We have to change this table meta thing. Okay, that makes sense. This is why we have packages, I guess. Because I think opt depends on catalog, so you can't put opt stuff inside a catalog, because you'd have a circular dependency. So we'll kill this thing. We'll kill this thing. And we have to look at what tab meta looks like. I see. So I guess what we probably want is like partial index predicates, and it'll take a map from index ID, which may or may not actually be a thing. What is this? Column meta. We'll just make it a map from int for now, and it'll be an ordinal into the table's indexes. Partial index predicates is a map from index ordinal on the table to scalar expr. The partial index predicate if it exists for that particular index. It's because the catalog represents the table catalog object, but you actually care about a particular instantiation of the table in the query that's been assigned column IDs, etc. That makes much sense. Much sense. This is an instance of a table and not just a general representation of what the table is in the catalog. Cool. Index. Okay. So then what we need to do is probably need to make a little method like this one. Basically is the same thing. Add partial index predicate. Add partial index predicate adds a partial index predicate to the table's metadata. Haha. Call ID. This is index ID, and it's just I don't know about this. Like, I'm sure there's like a better way to represent index IDs, but we can get to that later. TM dot partial index predicates. We're gonna initialize it if it doesn't exist. We're gonna make a map, blah, blah, blah. And we're gonna set it to our partial index predicate. Man, this would be, just feels such like some sort of generic or something, abstractions. It's like exactly the same thing as the method up here, just with different names. I love that. So back in our opt catalog, back in our select, we're gonna do the same thing over here. We're gonna search through each of our indexes. If we see a partial index, we're going to inflate it, and then we're gonna stick it onto our table meta, which was the whole point of this entire exercise. So, right. So we're gonna say our partial index pred string, or we'll just call it pred string, is equal to index dot partial index predicate dot predicate. We're gonna say expr error is equal to parser dot parse expr pred string. And if we get an error, we'll just panic, because I think that's fine in this context. It'll get caught. And now what? If table scope is empty, then append columns from table. Okay, so this is like some initialization stuff, I guess. Lazy initialization. Seems like I need exactly the same thing. Let's rename this tab meta to be consistent. This is, yeah, see, I mean, this is like another thing that's literally exactly the same. Maybe I should make a little method out of this thing. I'm gonna do that. Because I bet we do the same thing over here too. Add check constraints for table, add computed calls for table, add partial index predicates for table. It's really all the same. Let's make a little method, shall we? Shall we? It looks like we have to parameterize based on this requested type thing, because in a check expression and in a partial index predicate, we want a Boolean output, but in a computed column, you can be computing anything. It doesn't have to be Boolean. So I guess we need to parameterize our little function on that type. And I think it probably needs to be a little member of this builder thing, because we're actually going to be initializing part of the builder. Oh wait, no, never mind. Never mind. I think we just want it to be a function. We don't care about the builder at all. We have tab meta. We're gonna get passed in tab meta. So we're gonna call it initialize expr from string. Maybe initialize scoped expr from string or something. I don't know. It's gonna take a string, which is our expr string. It's going to take a types.t required type, and then it's also gonna take this tab meta business. Maybe let's put that first. Tab meta op.table meta. Actually, let's put it last, just because I feel like it. Tab meta op.table meta. All right, and so what are we gonna do here is that, oh wait, no. See ya, null bitmap. Thanks for stopping in. Have a great day. We're gonna be editing this. We also need this table scope. We're editing the table scope too, I guess, right? Yeah, so we're gonna take table scope. It's gonna be a scope. And we're gonna be editing the scope, right? And we're gonna be using the tab meta to figure out what to do with it, something like that. So first we'll parse it like we've been doing up here. Then we're gonna initialize it if we have to, this scope guy. Expr string. Initialize the table scope if it hasn't been initialized yet from the table's columns. Initialized, okay. And then we're gonna actually do this meat, the meat of the function, which is to actually inflate this parsed AST into something that the optimizer can understand. And so instead of making sure that it's an any type, we're gonna be making sure that it's our required type to make sure that it can work in both of these circumstances we were talking about. What's wrong with this? Oh, it needs to be a pointer. Okay. And then we can get rid of this thing because I think we're just gonna return at this point instead of, oh, we do need the builder. Okay, that's fine. Well, so we'll make this a method on this builder class thing. And we're gonna give it table scope. And I guess this stuff is probably all nil for everybody. That's fine. And we're just gonna actually return our scalar at this point, and then let the caller handle what to do next. Op.scalar expr. Now, if texpr is nil, I'm not exactly sure what that implies. What should we do? If the resolve type does not match the desired type, so this isn't the case of we're like parsing something, I don't know, we have a partial index predicate that for some reason is not a predicate, so it resolves to a non-Boolean, then I think that means like something is deeply wrong. And instead we should just like panic, I think, and that will turn into an error for the user. So let's just go ahead and do that. We'll just say, we'll actually just switch the way this is done. We'll say texpr is this thing. And then we'll say if texpr is equal to nil, something is deeply wrong. We have been passed an expr string that is not of the expected type. This should never happen because the expr string is an expression on a table, like a check or computed column, that should have been validated at some earlier time. And we can say unexpected type for I guess we can just say unexpected type for expression. We'll give a little sprintf to make this easier on ourselves. And we can say that we expected some other thing. And so we're gonna give it what we got, which is the exper dot, oh. I'm not sure if we can get a type out of this thing because it's just gonna say, sorry, I didn't exist. That's a little annoying. We'll just print the expression out. How about that? That will be fine for now. So the expression is going to be our exper string, and our expected type is going to be our required type. Cool. All right, so then now that we have a typed expression, which is sort of like an AST that has some associated type information on it, we can go ahead and turn this thing into our scalar opt expression, which is the original goal of this whole exercise. So we can say scalar exper is equal to build scalar, blah, blah, blah. And I think we can just return this thing and be done with our thing. Initialize scoped exper from string takes the string form of an expression, parses and type checks it according to the required type parameter, and inflates it into an opt.scalar exper using the provided table scope and table metadata. This should be used to turn special scalar expressions on tables like check expressions, computed columns, and partial index predicates into into a form that's useful for the optimizer to consume. Something like that. Okay. So now we can go ahead and use this thing all over the place, which would be nice. So we'll start with our partial index 1. So we'll say scalar is equal to initialize scoped exper from string, and it's going to take this thing pred string. It's going to take a boolean because in our partial index predicate land we know that we have to have a boolean predicate. Hey Spirit Researcher, how's it going? Hope your day is doing great. We are looking at partial indexes. We're making partial indexes in a database. Feel free to ask questions. Always happy to try to answer them. So we're gonna do this thing. We're gonna type check it as a Boolean, making sure that our partial index predicate is in fact a predicate, which means that it evaluates to Boolean. We're going to be passing in this table scope business, which sort of lets columns resolve to the table that we're looking at. We're also gonna be passing in this metadata. Same thing. It's going bad. I'm trying to fix Nginx web server. Dude, I've been there. I've absolutely been there. I'm so sorry to hear that you're running into issues. That thing is pretty hard to use, I think. You know what, this is totally tangent, but I really like the Caddy web server. Have you heard of that one? It's kind of like a more modern Nginx that's easier to use. It's a bit slimmer. It's a pretty cool thing. I would recommend checking that out if you've never heard of it. Caddy. Caddy web server. I'll type it in the chat. It does all the same things. It's like a reverse proxy, easier to configure. It does SSL for you. It's actually very cool. It connects to Let's Encrypt. Big fan of Caddy. All right, so we get our scalar expression, and then we can go ahead down here and actually use it up. And we'll use I for our index ID and the scalar thing. So we'll say add partial index predicate. Yay. Okay, that's very cool. And I think we can go ahead and do the same thing for our other usages and just complete this refactor. Leave the world in a slightly better place than how we found it, which is always a nice thing to do if you can. So down here, we're gonna say basically the same thing as this. Actually, we can go ahead and just, we're only using this thing once, so we'll just collapse it into a single line to make it look a little bit more snazzy. And really, this is the only thing that we need to have in our if at this point, which is kind of beautiful. So our scalar is going to be tab call dot computed expr string in this case, since we're talking about computed expressions and not partial index predicates anymore. Is it okay if you can help me? I'm getting stressed. I don't know if I can help you with this, my friend. I appreciate it though. I'm sorry that you're running into trouble. I don't think I could do that right this second, but I really hope that you find success at what you're trying to do. Good luck. Okay, so we do this, we add, instead of adding our partial index predicate, we're gonna say add computed call, and this is gonna be call ID, which we don't have yet, maybe? Call ID is equals tab meta, blah, blah, blah. Okay, we can go like this. Kill this whole thing. Cool. And then we could do the same thing for our last instance, which was in the case of check constraints. We'll basically go over here. We'll say initialize scoped expr from string. We'll pass in our check constraint.constraint. Oh, and down here, this has to be an any, not bool. And then we can add constraint scalar. And then get rid of all this stuff. Okay, that's a nice little quick refactor. That's a nice little quick refactor. We could maybe even pull it out into a commit. That would be a nice thing for us to do. But maybe we'll do that later. Cool. All right. So at this point, what we essentially have is we've added these partial index predicates to our table meta data, which is a really good thing. And I think it means that we can go back to our original job. And our original job is going to be actually using these things when we're making index spans to search through. So that's like really awesome. It's a long tangent, but I think it's gonna be great. Hey, Brohanster, welcome back. How are you doing? We just made some massive progress on this partial index predicate stuff. And what we can now do is we can inflate the optimizer expressions during index constraint generation and maybe compare them together. Yeah, I got them bots going, exactly. This is for when I blow up, you know? People are gonna come in here, they're gonna be streaming in. I'm gonna be programming something really cool and they're gonna be like, what are you doing? And I can say, just type !project, dude. And then they'll do it. So back here, now what we can actually do is fetch the scalar expression that the partial index predicate is. So that's like big, big, big progress. And all we have to do to do that is we have to get our table meta, which is here, md dot, where is our table meta? Table meta, tab ID. And we can say, give me my partial index predicate. I just love that. Isn't that nice? Index ord, I think, is what we want in this case. Index ord, probably. So our pred is equal to this thing. I guess if If not okay, then I don't even know. This is sort of a weird case. We're saying internal error. Thought the index was partial, but there wasn't a pre-initialized predicate expression available. It's like a super verbose error for something really, really dumb. Found partial index without pre-processed predicate. How about? All right, so that's out of the way. We can get rid of all this stuff because we basically did it, which is super cool. And then I think what we can do is, now we have the opportunity to compare this pred and our required filters. So we basically have to say, how do we sort of combine these? And I think what we have to do first is turn these things into constraints. So I think, oh wait. We want to actually set this thing partial index predicate because we already set that up. Partial, var, okay, bool, partial index predicate equals this thing. Oh my God, my Google thought that I just talked to it. Don't do that. Uncool, Google. All right, so now I think after we finish these like quick checks, this is probably where we want to do stuff. Or, maybe we can, who calls this thing? Just two places. I think what we should really do is add this to, oh, but we can get it. That's actually super cool because we have the metadata inside. So maybe what we want to do is just take this whole code and stick it inside of can maybe constrain index and return false in this quick check area. Nah, let's just let the quick checks live as they are and kind of do better down here. Because I think this is, everything down here is sort of where we're comparing these constraints and it gets like kind of algorithmic and slow. So maybe we'll just do that. So the first thing that we do is we init idx constraint for index. And I think what this is doing is that it's taking these filters and turning them into constraints, which is the entire dream. This is the entire dream. This constraint is this conjunction of disjunction of spans thing. And I think what we want to do at this point is we want to say check for partial index containment. Does the set of index constraints contain the partial index predicate constraints? If not, we have to return, we have to sort of bail out. We have to bail out and I guess return this thing here, nil nil false, because we weren't at all able to use the partial index to constrain our scan. Yeah. So actually, we'll just take this again and stick it down below, just to make things a little bit more clear. We can get rid of this declaration. If it's a partial index, then we get to do stuff, basically. And I think basically what we want to say is constraint dot union with. We want to union these two things just for now to get it working and see if they've changed. And if they haven't changed, that means that the thing on the left contains the thing on the right, and we're like sort of good to go. I think. I'm not sure what union does with disjunctions. It's truly unclear to me. Anyway, we can just try it. Union. It's a little annoying that this thing like just will edit. Maybe we just have to kind of copy it. Is there a way to copy these? Constraint dot copy. Init. Combine. Well, let's just copy it by hand. Constraint copy. Constraint dot constraint What's wrong with this? Oh, I see. That's a... We named this thing constraints, and we can't reference the package constraint. That is funny. And a bit obnoxious. We're gonna just rename it to something. C. Out constraint. Constraint dot constraint. And this thing has columns and spans. These probably need to be like deep copied though. It's gross, gross, gross. Don't love deep copy stuff. Well, I don't know. Do we even need this out constraint? Yeah, we definitely do, because the whole point is that we're, Oh, I mean, I guess actually it's maybe fine to just edit this thing, because the whole point is that if it does change, then we can just bail out. Oh, but we need to keep the original thing though. That's irritating. So this union thing looks complicated. I mean, one option is that we could change it, and essentially as we're editing it, if we ever notice that something's different, then we can just say that we can say that the left doesn't contain the right, something like that. I don't know. Let's just get something working real quick though. Let's just like make a very, very basic and dumb thing. We'll say, is there like an equality thing here? There isn't an equality thing. That's so annoying. It's so annoying. Well, I don't know. I mean, the very first thing that we have to do, even before we dive into this, we need to actually construct constraints as predicate. So let's actually start with that. I think there's something called constraint builder that we use to do this. And I think it's basically fairly straightforward. You just call this build constraints thing on the scalar expr and you get something out. So how do you initialize one of these guys though? How do you initialize one? You do it over here. Logical props builder. We can grab this. Basically. Make ourselves but it is a private method. How fun. Am I even allowed to import this memo thing in X form? Memo, yeah, I am. Thank goodness. Okay, that's great. That is lucky for us. Okay, so what we need to do is make like a public method on this memo guy that allows us to construct a constraint builder. Or maybe even better, we probably just want to make it construct this entire thing. So a method that sort of reaches in and does whatever I was just looking at that I have now lost. Build constraints. Build constraints. Let's make like a public version of this. So we'll say build constraints from expr, and we don't need to pass in a constraints builder because like the whole point is that we don't have one here. What we want to do is just pass in an op.scalar expr, and whatever we need to initialize our constraints builder in the first place, which I guess in this case is this metadata and eval context business. Yes. So we'll just make these parameters. How about? Put a comma. Always need one of those. And we can say this returns a constraint.set. And I think that you also need to return this like tight bool business, which I always like kind of forget what it is, but we can think about that later. For now, we know that we might have to return it, but Yeah, we can use this pattern. I guess if you name one variable that you're returning, you have to name them both. That's always fun. And it should be really simple though. What we're gonna do is we're gonna initialize a constraints builder, and it's gonna have an eval context set to eval context. I don't really know why you need this eval context. Maybe like you have to evaluate stuff. I don't know. And then you also, excuse me. You also have got this metadata business. Then we're just gonna say return cb.build constraints on this expr. All right, that was easy. Give it a quick doc string, build constraints from expr takes an optimizer, an opt.scalar expr, some metadata along with associated metadata. Now let's just not even bother to write that. And turns it into a set of constraints. Okay. Now back in our props guy, our partial funcs thing, we should just be able to use this, and then we'll finally have our two constraint sets that we're trying to match together. So get rid of this thing. We'll just say, we'll say like filter constraints. No. This is our partial index predicate constraint. So pred constraints, partial predicate constraints is equal to memo dot build constraints from expr. And we're gonna give it our partial index predicate itself. And we need to get this like metadata thing. I think we just have it in the scope, and we need an eval context, which hopefully we have somewhere too. It's always fun. There's one. I love how eval context is just this thing that like vaguely exists in most objects, and you can kind of get it out if you search for it. All right, so that's that. Now we have to sort of remember, what is this tight business about? Of course, this doesn't help us, doesn't tell us. I guess it basically means that here's an example. In the case of an OR expression, so we're talking about, here's a good example. So we're building a constraint for x is greater than 1 and y is greater than 10, or x is less than 5 and y is less than 50. The new constraint set might allow additional combinations of values that neither of the input sets allowed. Hey Roland, what's going on? Thanks for checking out my really cool Twitch bot command. I appreciate that. Dope bot, yeah, it's advanced. I don't know why, but it gives you a little character before the text. If you do it again, for example, it would print like a different one. I didn't see a way to turn that off. I thought it was kind of dumb. Maybe it's sort of like for leet points. I don't exactly know. Okay, point is though, why is this going to be a quote unquote loose constraint? The union is unconstrained and thus allows combinations like x, y equals 10, 0. I guess it's because in this case, well, this doesn't actually seem very true to me at all. I don't actually understand this at all. Like, how could this make any sense? If you have this particular union, this would not be satisfied by this expression. Oh, I guess the point is though that like you would only want to push part of it down into the scan or something like that. Well, out of curiosity, why don't we just go ahead and run such an example in the database? That might be sort of interesting. I don't really know. So if I made a table A, we already have a table A. If I made a table A and I gave it 2 columns, then I had an index also on this B column. And then what actually happens if I select from A, and then I give it this kind of crazy predicate where, hey Miguel, how's it going? Thank you for tuning in. Let me know if you have questions. We're working on a database where A is greater than 1 and Y is greater than 10, or A is less than 10 and Y is less than 100 or something. What does this do? Whoops, this probably wants a B. I'm doing pretty good. I'm enjoying myself. Thanks for the follow. I really appreciate that. What we want to do here is actually explain what's going on and see what the spans are. Somebody is calling me weirdly. That shouldn't be on the stream. All right, so what happens here is that this looks honestly like mildly sketchy to me. This is saying that we're going to use this second index to search the table. We're not going to allow any nulls, which I guess is true because in this particular case, we know that B cannot be null since one of these has to be true. And if either of these is true, then it's not null. And then it has to just use the whole filter. There's just no way around it, I suppose. That's kind of funky. It's kind of funky. Out of curiosity, what happens if we had an index on both the tables at once? Would that be doing something interesting? I don't really know how this works. Create index on A of A comma B. And we do the same thing. It probably won't do anything. Yeah, I didn't think so. What I don't really understand is like why we need to care about this. I think maybe we'll just ignore it for now. Which is always my policy if I don't understand something. We'll ignore it and we'll write some tests later, and if something is broken, we can come back and look at it later. Point is that we now have these predicates on the index that we know we have to statically satisfy if we're going to use this index. And I think basically the way that we can figure this out is if we union the two sets of constraints, so the constraints on the table, the partial index predicate, and then we union them with the set of constraints on the filters. And if we union those two things and we notice that they didn't change, then I think it means that we're in business because I think it means that the right one contains the other, maybe. I'm like a little bit unclear about whether that's actually true, but whatever. First, I think we do have to actually copy this thing though, annoyingly. So maybe we can give this guy a little like clone method or something like that. We'll give this guy a little clone method. And I think it's just gonna clone. We're gonna say it'll also return a new constraint. We'll say return is equal to new constraint. And then I think we annoyingly have to deep copy all of this stuff. So we can say ret.columns equals make columns, and the size of it's going to be the same as our input. So our len c of columns is going to be the size that we want. Then I think we can just go ahead and copy each of the little sub elements from the input into the output. So we can say ret.columns. We'll have to have a little loop, obviously, for I is equal to range ret.columns. Ret.columns of I is equal to input columns of I. The thing is, though, that like we have to sort of columns does not support indexing. Oh, right, obviously. I'm actually going to be iterating on this like internal thing. Does this thing need to be cloned? No, this is just an int. So we just need to clone this other calls business. All right, so we'll say ret.columns dot first call is equal to c.columns dot. Actually, let's just go like this, actually. So we'll say columns is equal to c.columns, and we can like edit the part that needs to be edited afterwards. And likewise for spans. c.spans, or spans is equal to the input spans. This thing will also need to be like deep copied. There's a lot of deep copying that has to go on here. It's pretty annoying. It is pretty annoying. Does this thing have a clone? I mean, like, there's got to be somewhere that we can clone things without having to redo it all from scratch. Maybe we just have to like re-init all of these things. Yeah, it definitely makes it seem like I should be doing this in a different way. And instead of unioning things, I should be doing them in a way that doesn't make me make a lot of copies. Are these types all generated or handwritten? Oh, you know that they're handwritten. You know that they're handwritten, and you know who they're written by. Radu Barinde and Andy Kimball. All right, so we don't have to clone this thing. We can just clone the ret.columns dot other calls is equals to make c.columns. Whoops, what is it? What does this thing contain actually again? It's got an opt ordering column. So we're gonna make a bunch of opt ordering columns, and we're gonna make it the length of the input columns dot other calls. Yeah. And then we can just go ahead and maybe we can just actually just do this like little silly trick where we say append nil to c.columns.otherCalls ... I think this will basically do what I want. It has to be a type. Okay, so opt.ordering calls. All right, that's faster. So then I guess we have to just also copy these like little spanny things. This is just so annoying. I mean, I think even in this, inside of a span, like there's keys, and a key is these datatives, and these need to be cloned as well. It would be nice. It would be nice if I did not have to do this. It would be really nice if I didn't have to do this. Maybe what we should try to do is instead just kind of attempt to make like an equality method rather than go down this like irritating cloning route, which is going to be inefficient anyway. Like literally, if I do this for the purposes of making it just like quickly, I'm going to have to rip it out anyway. And apparently it's not that quick. So I might as well just like do something slightly smarter. So what we want to say is, I guess we sort of want to say partial index usable is equal to out constraint. So we're going to want to say partial predicate constraints dot, and this is like contains or implies or something. Implies, contains. We'll do implies, maybe. And this, we want to check to see if the partial predicate constraints imply the required filters. I'm not really sure how this optional filters business fits into anything, but I mean, I assume that they're like sort of optional somehow. How long did it take me to learn SQL? I would say when I was learning to use SQL, I don't know. I don't know if I'm not exactly sure how long it took to learn SQL. I think it's a bit tricky. If you haven't worked inside of a language like SQL before, it's pretty different from other programming languages, but I believe in you. I think you can do it. There's some good tutorials out there on the internet. Isn't it the other way, like the filters should imply the predicates? Yes, it sure is. So I guess implies is sort of the opposite of contains. But I like the idea of having a contain. So I'm actually going to make it contains then, and not the other thing. Yeah. But Flash, I mean, what's kind of funny is that this stuff that we're working on the stream is kind of like the thing that runs the SQL. So you'd think that if you're writing the thing that knows how to run the SQL, you would know SQL really well. But in reality, I find that I often don't really remember a lot of things about SQL. So it just goes to show that SQL is, I don't know, it's a tricky language. It's a lot of ins and outs to it. So I think, how do we figure out whether a set contains another set? And wait a minute, we don't want to have required filters. We want to have this like constraint business. So I think we want like out constraint, probably. Out constraint. Wait, dude, this is so sketchy though. Look, like somebody is copying out constraint in a shallow way. I don't at all trust that. I don't trust that whatsoever. And so this is going to be contains another set. And it's going to return bool. So I think to figure out whether a constraint set contains another one, we sort of want to merge them together because they're sorted, it turns out, which is neat. It says here that I thought they were sorted. Set is a conjunction of constraints that are inferred from scalar filter conditions. I thought they were sorted. They are separated in order to optimize for the common case of a set with a single constraint. But that's the other kind of order. That's the wrong thing. Yeah, so constraints themselves are specified as ordered lists, but constraint sets are something completely different. That's sort of, I don't even know. A constraint can have many columns and it can have many spans, and I think that the number of columns is the same as the number of spans. And we can merge two constraints together, but what is the deal with merging constraint sets? I think like a constraint set is the or part. Yeah, I really don't know. Why don't we just like start by saying that we can only handle this if we have a single constraint, just to make the problem a little bit easier for the time being. So we'll say if s dot length is greater than 1 or other dot length is greater than 1, we'll just quit. Sorry, can't check containment between large between constraint sets with more than one constraint yet, just because I have no idea how to do it. So now we can just reduce the problem to checking whether a single constraint contains a single other constraint, which maybe should be easier. So we'll say C is equal to set dot first constraint, and we'll say other constraint. I will just say sort of like return C dot contains other dot first constraint. And then I think we have to sort of implement this contains thing down below in the constraint part. And now there is something already called contains span, but I think it's different. It's completely different, in fact. But let's figure out what it does to understand. Contains span returns true if the constraint contains a given span or a span that contains it. So what we're doing here is we're binary searching to find an overlapping span. And what is it? Is a constraint the one that's an or it's the and? Let's read it again. Constraint specifies the possible set of values that one or more columns will have in the result set. I mean, I think it's an and. Is it an and or an or? It seems to be. I don't understand why this example could have an or an and. I don't really get that. If this is a single column constraint, then that column's value will always be part of one of the spans in this constraint. Okay, so you could have, I guess you could have a thing where there's one column and many spans, it seems like. But how do you then link up the columns in the constraint with the spans in the constraint? Mild confusion. More than mild. Oh, maybe what it is that maybe, oh, I see. I think what it is like, if you have multiple columns in this thing, then the constraints are all on both of those columns at once, which means that this whole thing is like a big OR. And if you have multiple columns, then like within the big OR, there's like a couple of ands. I'm just gonna put a little comment to remind myself. A constraint is a disjunction of conjunctions. The conjunctions are over each of the columns in the constraint. Okay, so let's just get rid of this clone thing. That's never gonna work. And let's go back down to our contains method. Actually, first let's figure out again how this contain span thing works. Contain span. Contain span returns true, blah, blah, blah. And I think all the methods sort of know about the fact that there's multiple potential columns in each of the span. In fact, this doesn't even seem to care at all that there's multiple columns, which is sort of weird. So I think essentially what we need to figure out, hey Irfan, what is going on, dude? I think I told you guys on Twitter that I have a guest star. Irfan is my guest star. Why don't you send me a hangout? Thanks for the compliment on my background music. It's pretty good. I think, why don't you send me, should we do Slack call or Hangouts? What's gonna be like a cooler and better thing? Why don't we try Slack call actually, because Slack call we can like I can draw on your screen. That'd actually be super cool. All right, here we go. Let's make this happen. This is a new and different thing for us. I have like way too many windows. It's getting confusing. Are you gonna pick up? Well, if you're not gonna pick up, then I don't know. It's not working, he says. Okay, we'll try the Google version then. We'll try the Google version. How do I get that available? We're just gonna quickly pop on a hangout. Hangouts.google.com. Is this how things work? Oh yeah. Video call. How do I just like new conversation? Irfan. Let's go. Give us a call. All right, let's try this out. Oh no, I don't want two of my own faces. Zoom. We're doing Zoom. This is like a three-way. It's a three-way video chat thing. Oh boy. Hey, can you say something? Join with computer. All right. This is cool.
Is that working?
Yeah, it's working. I think it's working.
I'm gonna mute. Should I mute myself? No. What do I need to
No,
mute?
you don't. You're good, man. You're good. You can. You're now just like we're all on the same page. They can hear you. I can hear you. You can hear me.
Nice.
Who's 9am? What's up, 9am? Thanks for tuning in. So Irfan, let me ask you a question. How much do you know about constraint sets?
Let me figure this out 1 second.
All right, there's some technical difficulties. While he figures this out, I'm gonna keep thinking about how to get this constraint stuff working, and he can pick up the context.
Yeah.
So basically, we need to just figure out how to compare two constraint sets at once, or just two constraints, not even two constraint sets. I think the first thing that we could do is we can say that if the two constraint sets don't even have the same set of columns, we can just get out of here, right? Maybe. So let's just try it out. We can say if c dot columns, are these things sorted? Are these things sorted? Are these things sorted? I can't even tell. You know, I don't know if they are sorted. It kind of seems like, oh, but there's an equality method. That's nice. That's nice. So if they're not equal, constraint dot columns. Let's call this other. So if our constraint isn't even on the same set of columns as the other constraint, we know that we're not contained. We know that, whoa, you just like hijacked stuff. Oh, cool. This is cool. Zoom is a powerful beast.
Is it working now?
I think it's basically working. I want to make the window a bit bigger.
Might be able to double tap it.
Oh, there we go. There we go. Look at this. This is cool.
It's IDE within an IDE.
IDE within an IDE. You know what would be cool though is if we could sort of okay, whatever you just did is not good. I lost your IDE all of a sudden.
Should be back, I think. What the hell is happening?
Irfan is experiencing technical difficulties.
Okay, it's back.
Yeah. Cool. All right, Irfan. Before we switch gears to your thing, I'm gonna need you. I'm enlisting you. Okay. I'm enlisting you.
Yeah.
And the thing that we're doing, all right, is we're trying to make sure that I'm gonna give you a quick example here. I'm gonna make a table called B, and it's gonna have another, actually, we'll just go back to our users example. Drop table users. We're gonna make a new table called users, and it's gonna have an ID, which is an integer, and it's gonna have an active column, which is a Boolean, all right? And we're gonna say, create index on users of ID where active is true, all right? So this is a partial index, and we're only indexing the ID field of users if the user is active, right? So the question is, let's say we're the optimizer, and we're trying to figure out whether we're allowed to use the index or not, right? So we're gonna say explain select star from users where ID equals 10 and active is true. The question is, if we have this little filter here, so this active is true filter, we're trying to figure out how to compare the set of filters from the query with the set of filters on the partial index to make sure that one implies the other. Know what I'm saying?
Yeah. What is it doing now?
Well, what is it doing now is that it's completely broken. I just made, like, we're working on this partial indexing thing. It doesn't work yet. So the thing is, like, over here, I'm not sure if you see if you're watching my stream, it's probably like weirdly delayed, but just bear with me for a second. Over here, we have this thing called try constraint index. And try constraint index, what it's doing is it's getting in some filters from the query. This is this required filters thing. And it's getting in some filters from the partial index predicate, which we've made over here. And we sort of have these two things called constraint sets, and we're trying to compare the two and decide whether one implies the other. The question is, how does one do that?
Is this an optimizer code?
It is optimizer code.
Ooh, yeah, wrong. Where's Justin?
Justin was hanging out earlier, but he had to go.
What does it even, like, what's the form even say? Partial predicate constraint, what does it even have in there?
Yeah, so what's a partial index predicate constraint? It is this thing called an optimizer constraint. And this is what I was sort of messing with earlier. It's actually a little bit more annoying. It's an optimizer constraint set. And so what I think a constraint set is a disjunction. But I think it might be a conjunction of disjunction of conjunctions or something. It's something like kind of wild. It says it's a conjunction. Set is a conjunction of constraints that are inferred from scalar filter conditions. All right. And then within a constraint, I think the constraint itself is a disjunction. So it's like, you know, A is greater than 2 or A is less than 20 or something like that. So the thing we're trying to figure out is, like, how does one write an algorithm on constraint sets to figure out whether one constraint set implies the other constraint set?
One constraint set. Isn't that a stupid question? Isn't that like an NP-hard problem? If you want to compare two conjunctions, disjunctions.
I was thinking that it might have been one of those like crazy problems. Like, it sort of sounds like one of those like circuit testing problems or whatever.
I think it is, by the way.
I don't know though, because we do stuff like this all the time, and I don't think that we have the NP hard. You know, there's like other operations
right
on these sets that seem to be pretty quick, like intersection. You know what I mean?
Yeah. Like, what are the other operations like on the set that you can do today?
We can have an intersection. We can have a union.
And what does that intersection do?
So intersection, let's read it. It finds the overlap between this constraint set and the given set. That already sounds hard.
What does that even mean? Like, do we have like tests for this? Maybe it's useful to look at those.
Yeah, we got plenty of tests, my friend. But they're all kind of like cryptic. You know what I mean? I was looking at these earlier trying to figure them out, and they seemed a little bit tricky. So I think this is... C is this thing, and it has span greater than 20. So it's a span that says a particular column is greater than 20.
Yeah. Okay.
And then we have this span that does it inside of, I don't know, maybe C.
Yeah. And
then we're checking to see, in this case, just that like this evaluates to itself in the pretty printed form. And then down here, we're gonna intersect GT20 with LE40, which presumably is, yeah, the same thing, less than 40.
So it gives you 20 to 40. I mean, this kind of sounds like what we want, right?
Well, not exactly.
Oh, so I think intersect is just adding two it's adding two constraints together.
Yes.
And union is just the OR of two constraints. What do we want? We have a constraint.
What we want, we can write a little example. We have like, let's say we had 1 is greater than 20 and 1 is less than 100, for example. And this is our like, let's say this is our partial index predicate. Index predicate. And then down here, what we had was our actual table filter. And in this case, maybe we could say 1 is greater than 30 and 1 is less than 90. So in this case, we would want, so in this case, like actual table filter implies the partial index predicate. So it means we can use it. But if, for example, you had actual table filter as 1 is less than 10 and 1 is less than 90, then, you know, does not imply.
Right.
You know what I mean?
Yeah. Yeah, I don't think like we have those as like primitives today.
Yeah. Somebody was suggesting that you could just like union the two and see if they didn't change, and that might be the same thing. But that seems inefficient, and in order to do that, I sort of had to invent this like cloning method on the constraint set and stuff, and that was like too annoying, so I just like gave up and started writing it from scratch.
Like, are we matching like exact specifics, or is it just like implication? Like this implies the other.
It has to just be implication, because all this is, there's no specifics yet. Like all we have are just these like weird constraint things. They're filters and predicates. You know what I mean? Like we have no actual table values at this point.
Right. Let me think about this as well.
Do you like that fire engine noise, by the way?
Nice. What's happening in Brooklyn?
I don't know. Maybe a fire. You know, it'd be cool if I could like make this a floating window, but I bet I can't.
Probably can't.
Boom.
Oh. Zoom is powerful.
Yeah. So I think really that it's the same as like containment though, right? I think implication, like A implies B is the same as B contains A. That's why its stock is popping off. Yeah, exactly. Better invest in Zoom. No, I think the reason Zoom stock is popping off is for another reason, probably. Geopolitical, geomedical.
Oh, is P the same as P contains A? Is it? I guess it is. The predicate, then right off the bat, freaking hard question. It's a good entry for my stream. It's like an interview.
Yeah, welcome to your interview. This is like the algorithms section. I want to just like quickly do something really dumb, which I think is just to make this only work if both constraints only have a single span, and then check if they're exactly the same, and then see if that works. And then after that, we can switch gears to what you're doing.
Yeah.
So we'll say a set contains another set if the constraint contains the other constraint, first of all. Why does this, oh, because it wants a pointer. And we'll say that a constraint contains another constraint if, well, first of all, if the column sets aren't completely the same. Well, this also wants to be a subset, right? Because like I think if our left constraint contains a superset of our right constraint, then like it might be true, but we'll just like, return false for now. We know that's something, but let's just skip it for now. So if we have all the same constraints, and then we can say that I think these spans are also sorted too. So if we could just compare them, they're all always ordered and non-overlapping. So I think we could just compare them all, and then be done with our lives. So we can say, first of all, if C dot spans, if the length of the spans of our constraint is not equal to the length of the other guy's spans. Oh, we can't take the length though. Count.
Are you sure this is not an NP hard problem? It feels like it is.
I really don't think it is. I think it's like because everything's like also sorted and stuff. I think it's like
aren't we interested in just arbitrary constraints though?
I think, well, yeah, it gets kind of crazy if you're thinking about like built-in functions in the database or something like that. But I think if
Yeah.
it's just like math functions, I don't actually think it's that bad. If the functions can like, you know, resolve down to ranges of integers or whatever, which is how everything else works, I don't think it is NP hard. I'm not positive, but
Oh, okay. So only range spans then.
yeah.
Oh, okay. No, I thought we were interested in arbitrary things.
But like, what other things would there be? Range spans is like the thing that we have in this database, you know?
Yeah, I actually don't know what the constraints, like what constraints even means here. I just saw this Boolean expression.
Oh yeah, no,
It
well
could be anything.
it's these like span things.
Okay. Oh, so we're just checking if they completely overlap. If one range completely overlaps with the other, and then we just iterate over both of them in order, and then make sure that each kind of thing is covered by the time you get to the end of it.
Yeah.
Isn't that what we want?
I think there are some complications because there's like OR expressions in there, which throw things into a more confusing state. And also there's like,
I mean,
yeah.
So whatever the smaller constraint is, essentially kind of like iterate over that, jump across those boundaries as we need to, and check if whatever thing you're covering is entirely covered by some span in the original constraint set. Like you're essentially kind of like mapping like a linear whatever subset into like another linear subset and seeing if like one's a complete subset of the other, right?
Yeah, I think probably something like that. How does Postgres do this? I don't know. Probably it does something similar in like a different sort of way. I don't know if they even use these span constraint. I just don't know. You could find out though. Report back. Let us know. So we'll say, for now, we'll just compare them for quality. And then we can maybe have just a very dumb and basic example. c.spans.get of I dot equals. Can I have an equals, please? No equals in this thing? Sad. Compare? Wonder what compare does. Compare returns an integer indicating the ordering of the two spans. 0 if they're equal, -1 if less, or... Okay, so there's like some kind of weird like ordering on this thing that is sort of confusing because like it's two numbers so they could overlap, but we'll just for now like make sure that they're exactly equal. So we'll make sure that this result of this compare is equal to 0. So if this guy compares to the other guy, this other dot spans dot get of I equals 0, does this work? Does this need to be a pointer or something? No. Oh, it needs a key context. What the? Do I have one of those? Do I need to pass in a key context? What is a key context? Does an eval context have a key context? Key context. Oh, no. People are just like passing it in all over the place. So we'll just do that too. All right, so we pass in our key context. We pass in our other spans. Or I guess in this case, if it's not equal to 0, then we'll just like bail out and return false, and otherwise we'll return true. And then I think we have like a very simple and bad way of doing this that is way too something. So then if we go all the way back up to our actual code here, let's just ignore this type business because I don't really know what it means. Figure out whether I need to pay attention to the tight return value. We're going to say it's usable if this constraint contains the... Why doesn't this work? Oh, because everybody, first of all, needs a key context. Key context. Key context, that's done. And then back here, we need to pass in our own key context. I mean, I hope we have a key context. Where do we get our, where do we get our key context?
Can we just pass it like a nil or something for now?
No, I definitely need that key context. Definitely need it, probably. It's gotta be around here somewhere. Maybe. Single span constraint. Where do we get these stupid key contexts from? Oh, I see. You can just like make them on the fly.
Make key context, yeah. Columns and eval context, that's all you need.
It's just called make key context?
Yeah, or you could do that too.
Constraint.make key context calls, which I guess should be down here. And I think where are our calls in this case? Maybe it's like md dot. Where do we get our stupid calls? It's got to be another example of this.
What does this even do?
Oh, the constraint has the columns. Okay, that's cool.
Okay.
I don't really know what it does. Let's not think about it too much. Thinking about how the optimizer works too much is always like a downfall. You just have to like try your best to copy what everybody else around you is doing. So I think we use our partial predicate constraints dot calls. Extract calls. Okay, sure. It doesn't like this either. Oh, it's a no. Does our out constraint? What does our out constraint have? Oh, here it is. Does this work? This is a... Yes! We found a thing. Okay, now we just need to pass in our eval context, which I think we do have in our... I used it somewhere else. There it is. All right, sweet. Pass in our key context. This needs to be a pointer. And then what's wrong with this? Why does this not... Out constraint is a constraint. We want a constraint set. What? We just need to make a constraint set with one thing in it, I guess. Constraint dot make. No. Get me a constraint set. Single constraint. It's just called single constraint. Constraint dot single constraint out constraint. All right, pass in our set, and then we know whether we're usable. If we are usable, then if we're not usable, if not partial index usable, I guess we could just do this inline, but whatever. Then we return nil, nil, false. And I think that's basically all we have to do, maybe. So let's actually just go ahead and...
Will this like show up in the plan?
Yeah, it'll show up in the plan. Basically, it'll say like, it'll either say like, oh no. Oh God, what did I do?
Import cycle.
Yeah, but what did I see. I gave, this is the thing. Oh, right. This is just some earlier experiment. I can just delete this. I already learned this lesson, and I don't need to worry about it any longer. I think we can just move on with our lives here, hopefully. How's the weather up in Canada?
Not bad. It's not been snowing these last few months, like weeks, I want to say. It's been a lot warmer than before. Global warming, dude.
I know, man.
It works well.
I think this winter's been really warm. It's disturbing. It didn't snow in New York, I don't think, like at all.
Oh yeah, I heard that. It was still pretty cold when I was over, but yeah, no snow. Yeah,
I think it was like cold that 1 week when you were here, but it hasn't exactly stayed cold.
So I saw this like this article about some like a bunch of New Yorkers who can't go skiing anymore, so they just have these big rollerblades and they're just going around Central Park because they can't ski.
That's like cool, I think. I'm into rollerblading. There was a blizzard in January, dude. I missed that. I was away, and I'm sad about that. Did it stick, though? All right, so... Oh, wait. We want to use our server that already has the table. It was a wild day. I'm jealous. So now, hopefully, if we run this explain, it'll still use the index. Okay, it crashed. Well, that's another fun thing. Crashes.
Wait, what is C-SQL? Is that just...
It's just an alias
connects?
for cockroach -- SQL insecure or something. Found partial index without preprocessed predicate. Oh, I know what this is about. I just forgot to add it. I think this is the last thing. If it doesn't get fixed after this last thing, we'll just switch immediately.
I don't know. Maybe we should continue. I feel like this is more engaging than whatever I had.
We could just pair on this. I'm down. Let me get your face back. So basically, the thing that's wrong is that I forgot to call this thing. So basically, I added to the table metadata thing this set of partial index predicates. And I think I just forgot to add anything to it using this add partial index predicate method. Like I was supposed to just add all the things and I just didn't. No, I did. I did add the things. Oh, but I just never called this. Okay, simple. I just never called this thing. So I think all we have to do is just add a call to this where all the other calls to similar things are. So b.add partial index predicates for table tab meta. Let me try again. I think I could also probably decide to use test for this instead of just rebuilding it every time, but like, I don't know, this is like more engaging. It's like so exciting, you know? It's like you live or you die. Hold on, maybe I should make this window smaller so I can type in my terminal and see you at the same time. Oh no. Okay. Whoop.
No wonder Andre was complaining. It's a lot.
Yeah, it's like super noisy, right? I feel bad about that. I feel like that, yeah, that patch about the make file, we just shouldn't have even done it. Because realistically, like compiling call exec is really fast.
Yeah, I feel bad about like looping in you and then Raphael as well.
Yeah, now it's like now it's like we can't go back. Okay, sweet. Except the problem is that in this case, whoops. Well, this is also super broke. I need to get back to fixing whatever is going wrong with this, but I think that this is bad because this should have gotten to use the index. And it didn't.
And what is it doing now? Nothing at all?
Now it's just, well, let's use explain opt, but it's just the same thing. It wasn't able to like push the filter into the index for some reason, even though, and it's basically because of this line that we added back in generate constrained scans. I think basically the problem is that in this try constraint index thing, we're just leaving here. I think this partial index usable thing is probably set to false in our case. I'm gonna print something out. I'll just like write a quick test for this to make sure that it's even getting this bar. Print line partial index usable is, and then we'll also print out maybe like the partial predicate constraints to see what that looks like. And then we can do, what the heck is this? Let's get rid of this. That's like some weird thing that I was hacking on. Exec builder test data partial indexes. At the bottom, let's add a, oh wait, do we want an exec builder thing? I think we actually want like an opt builder test or something.
Well, what even is this? I'm not familiar. Are these logic tests?
They're kind of like logic tests, except they're testing, instead of testing like regular SQL input and output, they're testing.
Oh, just a plan?
The plan, or in this particular case, it's like the actual KV commands that get generated. I think the opt builder tests are actually the plan, which is why I sort of want to look at some of those. And I don't think I have one for partial indexes yet, so let's edit that, and we'll also grab the select one to just sort of copy it. So we're gonna say exec.ddl. We're gonna make a new table, users. We'll give it ID int primary key. We'll give it active bool. And then we'll say index on ID where active is true. Is there an is? I forget. I think there is. And then we'll use this build thing. And we'll say select star from users where ID equals 10 and active is true. And we'll do the same thing down here where active is false. Then we'll do also the thing when it's not constrained at all.
We're getting spammed.
What's up, Ridwan?
Oh, who's the other guy?
Rith Beld Ayunomal. What's up? This does seem like a mega spam thing. Dude, this is such a spam
Famous.
bot. I feel happy. I've been invaded by spammers. It's a good thing they didn't say anything bad. Yes, getting big. Where are the mods? Rohan, I'll make you a mod. I don't know how to do that. Okay, so let's run these tests. We're gonna say make test package equals SQL opt builder test flags equals rewrite.
Is this like assert anything right now, or is it just gonna print out whatever gets printed out?
It's not gonna, since I gave it the rewrite flag, it's just gonna actually just redo everything. What's up, Pouch? How are you doing? Okay, so what it gives us is nothing at all good. It's showing us that, just like we saw before, there's nothing getting constrained. So I think what we want to do is like just run this one and look at what the test, the like little logging that I did added, test flags equals -b. It would also be nice to like constrain it to just the test, but I forget what that format is, so let's just run. Oh my god, this is so annoying, dude. All these exec gen outputs. Okay. This is so much. Wait, how do I just give it the name of the test though? Op builder. There must be like a test thingy.
Or just like log something and grep for that.
Test builder. Yeah, that's a good point. I could do that. Oh, it was right here the whole time. Okay. Tests equal test builder / partial indexes. Okay, this should be really nice and oh my god. We have to turn that off. It's gonna drive me absolutely mad.
Rebase master. You know,
Okay.
you're just missing one thing. If you just put an ampersand there, it would just go away.
Yeah, I guess so. I guess so.
If you want to do that now.
I'm not gonna do that now. So we do have some. What was my logging look like again? I feel like we didn't even get to my logging, which is disturbing and sad. Get rid of this thing. What file? I was in like this custom funcs thing, I think. Try constraint. I have always a problem like remembering what file I'm editing in this code base. It's so big. So I didn't even print this out. I did not even print this out.
There?
I think we would get something.
Oh.
Oh, you know, here's something interesting. I think one change that I did make before I last tested this,
Yeah.
was that before I think I actually removed the partial indexes from the non-constrained scan thing. So basically the optimizer, the way it works is it's going to generate scans. It's going to generate all full table scans over all indexes in one method called generate scans. And then it's going to generate all of the constrained scans that it possibly can in this other thing. And so maybe what's actually happening is that for some reason, we're not even getting to. Oh yeah, I think I've made. No, I don't know. I'm actually confused.
Can you try whipping up the debugger for this instead of like logging back and forth?
Yeah, we could do that. It's a good idea. Well, let's just go.
How do you like run one of those op builder tests through the debugger? I have no idea.
I think it's pretty easy. I think we're just gonna basically run this debug thing, but then I think we actually just want to kill it real quick and then like edit this flags thingy so we can just say give me just test builder / partial indexes or something.
Oh, nice.
But
how'd you get the 9 cat there?
It's like some stupid plugin. All right, so then I guess I want to add the breakpoint up over. Okay, well that was actually really fast, so that gives me hope that it won't be too slow to like deal with this. So let's actually just break inside of track constraint index.
Yep.
See what happens. It doesn't even get there at all. So that's hilarious.
One level above, maybe?
Yeah, maybe one level above. I'm actually a little bit confused. I wonder if like it's the way that I've done. I don't know. Let's just like break right here, I guess.
We go to the start of the function.
This is the start of the. Oh no, it's not. You're right.
Even further up, actually. Yeah, there.
Huh.
No?
That's shot. I feel like there's something wrong with the way that I'm running this test then, because this like definitely should be running. Unless somehow I've broken it with that thing I was telling you about before. So like, I'll show you what I did. Generate scans. No, wait. Constrained scans? Generate scans? Isn't there a thing? Oh, generate index scans is what it's called. So basically over here, I just like bailed out completely. And I wonder if I just like comment this out, what it'll do. I mean, I know what it'll do is it'll like just give us a full table scan over the index. Well, I don't know. Actually, I'm confused. I don't know. Let's just see what happens without this.
What was the purpose of this again? Like, why did you add that?
The reason I added that, I mean, there's something wrong with this for sure, but the reason that I added that is that I think that the results of this function are all full index scans. And you can never have a full index scan over a partial index unless the partial index predicate is like trivial, like true equals true or something.
Well, this doesn't work either.
Yeah, I think that there must be something like wrong with the way I've written the test. So let's go again and look at the test. I'm a little confused because maybe like this doesn't work and I just need to go like, maybe I like forgot to hook up that part of things. That would actually be super hilarious and I wouldn't be surprised if that's what it is. So we'll do it on a separate line. Create index ID where active equals true, index on user's ID. I'll try again. Dude, I don't know. All right, so this is better. This is better. Now things are like crashing and exploding and.
Nice. Okay.
Wait.
Oh.
No. I just need the word on. Dang it. Dang it. Actually, let's just go back to the debugger. I feel like it'll be better that way. What do you think about my techno?
I can't hear it anymore, actually.
That makes sense.
I wonder if the stream can.
The stream definitely can. I think. Yeah, for sure.
Yeah, they can.
Oh, it's because I didn't add it to the stupid test catalog. I think that this is annoying. You can't create an index in the test catalog. So I have to do it the other way, but maybe I didn't like add support for it. I don't know, dude. I don't know.
Did you have this like last time? Is this like an option specific thing?
Huh?
Like this test catalog thing, did you not have this last time before you were working on the optimizer itself?
No, I mean, this test catalog thing is part of the optimizer, and they use it just for testing the optimizer. I think I just need to quickly just like teach it to do this. If it's an index table def, I think I just need to say partial index predicate is going to be def dot partial index predicate or something. Oh wait, no, I do it right down here. I already did this, huh? So wait, that can't be it. So in this case, actually, we should be back to being confused why the breakpoint isn't firing. Let's just like break in even generate index scans to see if it's even getting there. What? There must be something either wrong with my debugger or like completely wrong about my understanding about how anything works.
Can you like break even higher up, seeing like if it catches anything at all?
Yeah, well, outside of here, it like gets kind of confusing. We get into like crazy optimizer town, but I think what we could do is break inside of this like build select.go thing. This thing definitely will get called. Okay, so that did in fact work. The problem is like, it's gonna be really hard for me to step into where that was because it's just like, I don't even know. And if I continue, I feel like it'll, oh, we're just back. There's just one scan per thing.
Yeah.
Oh, this is dumb. It's just, these tests aren't doing, they only do building. They don't do the constraint part. I'm just like writing the wrong kind of test. I forgot about that. So this is why I don't work on the optimizer. I don't know this stuff.
Wait, so it doesn't run anything? It just, what is building only?
I think building only is like it builds the optimizer expressions, but it doesn't like optimize them, so to speak.
Oh, okay.
But I bet there's a test for this too somewhere. I bet it's in like explore or transform or something. Test data. Oh yeah, this is looking better. Rules. Scan. Yeah, this is better. See, this is actually testing generate index scans.
Nice.
Okay, so we'll try again. Let's also grab the thing that we just did. Package SQL opt builder, test data, partial indexes, and just copy it. And then instead of writing build, we write opt. Yeah, I forgot about this. Okay, then we can run make test package equals package SQL opt xform test equals, now what's the test called? Xform main test? No, optimizer test. Test rules. Whoops. Test rules. Test rules.
They do rule.
And then partial indexes. What'd you say?
Test do rule.
Test do rule.
Yeah.
Okay, that's good. Then we just want to rewrite them and see what we actually have, and then we can re-examine what's happening. Oh, and I printed out our debug log. This is fantastic. Look, partial index usable is
Oh,
false.
right there?
Yeah.
Nice. Okay, we can go back into the debugger now, I think, right?
Yeah, true. All right, sick. So in our debugger, we're actually gonna run this other thing, test rules. Create test rules, configuration, partial indexes. Okay. Then we debug it. Here we go. Let's go, baby. We're gonna debug stuff.
I'm also curious, like, what those constraints actually look like once you get to this.
Yeah,
like,
good point.
The...
Good point. I'm also confused / curious about that. Okay, so here we are in generate constraint scans. And then we should block here. Okay. So let's just go down a little bit. Let's go inside of try constraint index. Now inside of try constraint index, let's see what we have here. We have 2 required filters.
Is this all you? This code? No.
No. Thank God. That would be bad. So I guess our required filters are just probably the constraint on ID and then also the constraint on active. But it's sort of hard to see it because, like, yeah, you know, this stuff is just wild. But I think we can just assume that this is right because we didn't make it up. And then let's go down and see what happens when we... I wonder if we just exit early here. Maybe this is the problem.
Why?
I don't know. No, we don't exit early. So we initialize some constraints, we do some stuff. Do we exit early here? Maybe that's the problem. Nope. So if it's a partial index, oh God, were we just doing the primary index that whole time? We were probably just doing the primary index that whole time. So we have to continue on. Now we're in generate constraint. Okay, so this should be the right one, hopefully. Can we test it somehow?
Shouldn't it be just a breakpoint inside that block?
Yeah, I mean, we're in a loop now, so I think we just want to look at what, like, our index is. Yeah, maybe you're right. We should just iter.index ordinal. This should be like 2, I think. It's 1. Oh, maybe it's 0 index though. So we can hope. I think. Wait, do I have it?
You do.
I'm lost. I think I killed it. I killed it by accident. We have to try again. This always happens to me with this stupid debugger. Conditional breakpoints would be better, right?
They do exist.
Yeah. Is that Bilal over there?
That is.
Nice.
Working away. I'm disturbing him.
Okay, so in try constraint index, this is index or 0, so we don't care about it. I bet in this case, okay, check this out. I bet it's just gonna be like, I'm finished and I don't need to do any more work, and that was the problem. So we continue along. Let's go inside of try constraint index. Our index ord should be 1, so that's good. Now I bet it's gonna die right here or something.
Did we ever hit this before? We did, right?
Yeah, okay, so that's not the problem. I was wrong. Now we should be inside of here, hopefully. Yay, okay, you're right. Let's just have a breakpoint here, and then that will be a better thing in the future.
Just remove everything else.
Okay, so here's our partial index predicate constraints, which is the original dream. We have a single constraint.
What does that look like?
It's got a single column, which is 2. which I guess is the active thing. And we have a single span, which goes from, this is presumably true, and this is presumably also true. Yeah. Oh, I know what the problem is, dude. The problem is that I made that overly specific check to see whether they have the same number of spans. Because one of them has more.
Right. Oh.
You know? So I think what we have to do is, let's go into here. I think it's gonna like fail with this or something.
Can we just, is there a way for us to just like return true it contains and see what happens if it even like registers that plan?
I think it will, and I think it'll just do what it did before, which is just always get to use the index, and that would be sort of, I think this is definitely the problem. So like, it's gonna go into here, and then this is gonna be false or something. C.columns is equal to, it's got one thing, and this one's got, oh, they're just different. What?
Wait, what are we comparing? See the columns, other columns?
We're comparing like...
You can print it out right now as well. You can like insert evaluation or something.
Oh, really?
You can yeah, check it out.
Wait, how? Like with this or something? No.
Like there is like an option here somewhere.
This thing used to not work, but maybe it works now.
Exactly this actually. So constrained or like other dot whatever column dot print or string or something. Not that. So you want to evaluate something.
I see what you mean.
Yeah. Columns dot string, I think. Yeah, try that.
So the problem is that it's the other constraint. It's like numeric constraint.
And what is ours?
Ours is the true-false constraint. Well, I mean, maybe this is natural, and it's like evaluating them one by one or something. So let's like get out of here, and maybe it'll give us another chance or something. So this is now gonna fail. We bounce. And then we leave, and we continue. Oh, but then we're just like out of here. Okay, so it's like something is sort of screwed up in that we're not getting all of the possible filters or something.
Why is it numeric for the other one?
It's because, so remember our test is over here. Our test is that ID is 10 and active is true. So I think what's happening is that like we're getting this constraint and we're trying to compare it with the active is true constraint over here. What's up, Big Nose 25? How's it going? I hope you're enjoying yourself. Let me know if you have any questions. I'm always happy to talk about things that you want to talk about. But we're just kind of debugging some stuff right now. Yeah. So realistically, I don't exactly know why we would be having to compare those two sets of constraints in kind of a weird way.
Yeah, aren't we supposed to like fall back to the constraints on the table itself, like the index itself? Wasn't that the idea?
I think the idea is that like, wait, fall back to the constraints on the table itself?
Like the thing we're comparing our partial indexes with is what? It's not the query. It's not the constraints on the query itself. It's on the underlying table. The indexes on the underlying table, right?
Yeah. So we're comparing like this predicate here, active is true, which is on the table, to. I thought we were going to get to compare it against this entire thing. Oh, I think I know what it is. I think it's that like somewhere higher up in the optimizer, it knows that it's only going to try to bring down the part of the predicate that it's actually relevant to the thing. But we need to see like the rest of it. You know? Like normally the optimizer wouldn't even try to pass the active is true thing down to this index because it knows that the index has nothing to do with active.
What if we just remove ID equals 10 there? Does that help us?
That's a good question. That's a simpler test. I like that. Wait, just a, hold on. Getting confused.
There's a bot in the stream now. Do you also take like those coins those streamers do?
No.
Bits?
In order to do that, you have to like be affiliate, which means that you have to like stream a lot, basically. I'm not at that level, dude. I'm not at that level. Maybe if I can get like, I don't know, more viewers. I think right now most of the viewers are probably like people that we know, but I'm not positive. Okay, what happened here? Oh, I was editing the wrong one. I was editing the op builder one.
Surprisingly small demographic of database implementation streamer.
I know. Well, you know, MongoDB actually has a stream.
Oh, actually?
Yeah.
Dang.
And they get like, I don't know, 30 viewers and stuff. I think like the most popular programming people on Twitch get like 70 viewers. It's like kind of
I actually saw the Redis guy. The Redis guy did a few.
Oh, really?
His was really cool. Yeah, and it was a lot of views.
That's cool.
On YouTube at least, like a few thousand.
Nice.
So. But it's also like, just like it's C. It's like painful as hell.
Yeah. All right, so in this case, we just kept active is true only. And of course, nothing happens here either because, I mean, that makes sense though, because like, there's no point to using the special index if we're not constraining it at all. Like the index that we're actually, like the column that has to be constrained to use is this ID column.
Can I build a partial index over a range of IDs? Is that a thing?
Yeah, for sure. You could say, yeah, maybe that's even a simpler test. I like that. Let's try that out. Create table, simple test, just simple. We'll have ID int. We'll do index of ID where ID is less than 10 and ID is greater than 0. This is like the world's stupidest index. And then we'll say select star from simple where ID is equal to 5. Right? This is what you're thinking.
Something like that, yeah. And this is fully constrained within the top level.
Yeah.
Constraint. Okay.
Yeah, it's like this is like the lucky case that will probably work. No, it doesn't even work.
Strings.
It doesn't work.
Okay. Sorry. One more thing.
Yeah.
Can we maybe add another column, not ID? Maybe some primary index funkiness is happening. What if it's?
I don't think so. I mean, this already has an implicit primary key, but it's fine.
Yeah.
But we can test, no problem. So,
No.
I mean, actually, you know, I don't know what it's supposed to look like. So let's look at what it's supposed to look like. It's supposed to... Wait, this is... Generate index scans. Generate constraint index scans. Okay. What the heck? Are these like... Explore trace? Whoa, look at this. This is like a crazy kind of test. It's doing something really... Maybe we should use this kind of test, because then we can see like more details about what it's doing.
Yeah.
Explore trace and memo test. Wow. Let's try that. Oh yeah, but it's supposed to look like this: scan a at, and then it gives a particular index. So that's our goal.
Oh shit. Which line? Oh, okay. Nice.
So we'll try. Well, let's see what happens when we add this explore trace business, just out of curiosity. Explore trace.
That's secondary.
What the heck is at secondary? I've never even... Is that just what?
Does your partial index have a name?
Let's call it foo. Okay.
Yes. Is that what we want?
I don't, well, this is saying, I mean, we know that we could use it in this case because we know that ID equals 5. I guess the question is down here. No, this is not good. This is not good. Because I think this should never get generated because we're never allowed to do a full index scan over a partial index. Well, right, because we disabled that rule. Let's just like re-add that rule real quick because it should really be in there.
Full index scan over partial, okay.
Right, because unless it's a vapid sort of generate index scans. So we'll add this back in. Okay, let's run this one more time. Actually, before we do that though, let's go down here. Generate constrained scans. It claims have no new expressions, which I think seems bad.
Can we also like add a test that like looks for an index outside the partial index scan and see what happens there? Like IDX equals 6 or something. Or...
Yeah, I think that's this one, right? Or IDX?
Or sorry, ID equals whatever, something outside the bound.
Yeah, I think this is the one that was supposed to be like that, but I forgot to add export trace to it. So let's just see what happens in this case. In this case, we've got, okay, so this is good. We now know that generate index scans does not give us the full index scan over our partial index, which I'm happy about. And then in generated constraint scans though, it's the same thing. We don't get anything fresh. So that's like the problem for sure. Yeah. I guess we should probably hop back into our debugger for this.
Like is there a line of code that you can like point at, like if everything works that would get executed?
Yeah. So I think what should happen is that we're looping through our indexes and generate constrained scans. We should get down into this section. This thing, forget this partition filters business. Forget all this stuff. Wait. No, maybe I went too quick. I think that we should be able to get right here after try constraint index. We should be able to land here and be happy. So let's just debug on that, I guess. Yeah.
Ridwan has a message in the chat.
Ridwan, could also be a costing issue. Maybe there is an opt plan with the partial index scan, but because of the estimates and whatnot, it's not the plan that's chosen. Yeah, I think that would be a possibility, but I think that in this case, it's not. Because I don't think that we even get, I mean, we were in the debugger and we noticed that it didn't even get to like the spot that we wanted to get to. But that's a very good point. Like I might need to update the costing function, I guess. I don't know how that stuff works at all. So this is pretty good though. Like this is basically where we're supposed to be. Partial predicate constraints. And the problem is I think we're just gonna get to this spot and we'll see partial index usable as false. Right, so the thread that I wanted to explore last time though, was why is it the case that the other constraints that we're getting don't include like the ones that we're trying to mess with? That's sort of like the kicker. It's why does required filters not contain the like, oh wait a minute, in this case though, this is like the simple case, right? There isn't like a separate column. So actually in this case, we should have the right things. So let's just like step through again. Oh, whoops. Did I go too fast? No, it's okay. So our set in this case has one constraint and it's on 2. So that's, I guess, the ID column. And it's got one span, which starts at 1 and ends at 9, which is what we sort of expect. And the other span is on column 2 also, so that's good. And it starts, and it starts at 5 and it ends at 5. So this like should definitely match. This should like definitely work. So let's jump into this. Yeah,
where is it erroring out here? Yeah.
I'm not sure. Yeah, let's find out.
Contains?
I don't know. So if columns is not equal to other columns, we quit. So that should, wait, what? Well, this is obviously the problem. I mean, this shouldn't be the case though.
Yeah.
Because columns 2 and the other one has columns. Oh, but it has other calls. What? What? Why would that be the case? Like what?
What is other calls here?
I don't know.
Is it the is it the primary? Is it the A column that you just added?
Yeah, I guess it must be. Maybe what we want is like, dude, that's so weird.
Okay, why are we matching the columns again?
I don't know. Maybe we don't even need to. Because like the span information should have all of that, I think.
Yeah.
Sort of.
Maybe.
I don't think it really does. It's a little bit confusing because these spans, like, they don't have any information about columns at all. It's just like datums, you know? Uh-oh, somebody's calling me. Let's turn that off. How about? Hey, thanks for the follow. Ninja. Please with this thing. Oh my god. Get away. Alright. Okay, so why don't we just like, yeah, I think the when like these columns wouldn't be equal, we would see multiple things inside of these constraint keys or something like that.
But at least one of them is equal? Maybe? I don't know. Wait, okay, so spans like yeah, I still don't quite know why we're comparing columns. Constraints is over what?
A constraint, let's go read the documentation on it again because it's pretty good.
Over one or more columns. It's a single column. Okay, so what we had was a single column constraint.
Yeah. Well, one of them was a single column constraint, and the other one was a multi-column constraint that only had a single thing in it or something.
Right, like I mean the one we constructed, we made a single column constraint at some point, right?
No, that was a single constraint set. It's different.
Oh, okay.
Yeah, I mean, this is just odd that you can have a constraint that has multiple columns, but the spans are only on a single column. It's like kind of confusing.
I think they're not. The span key values correspond to those columns by position. No? So the spans are not over a single column.
I think they are.
Like, look at the second paragraph.
Constrained columns are specified as an ordered list, and span key values correspond to these columns by position.
Yeah. So they're not. I think it's like span 1, something for column 1, span 2, column 2. No?
No, I don't think so. Because here, look at this example. Down here.
Multiple. Okay. Yeah, I don't know how this is structured. The actual values that we're seeing, how many spans and how many spans are there for the multi-column one?
It's a single span. We're looking over here. Other columns.
Yeah.
First call 2, other calls 1, and then in spans we have a first span but no other spans.
Yeah, let me look it up.
I think that maybe it's fine to just definitely for the purposes of this very, very simple example, it would be fine to just remove that check. Because it would just like artificially make it work.
Yeah.
Let's just try that just for the purposes of moving on from this pane. See what it gets us. I don't really get that. I mean, it would be good to involve. I think like Radu would probably understand what was going on with that better than us, at least. This is cool. This is cool. Unsupported comparison bool to int.
Where's that?
I think that means that our contains method is just like totally busted, or we're not allowed to always be comparing. Like we sort of have mismatched constraints or something like that. It again goes back to that thing. Oh, you know, I bet this is actually down at the more advanced test where we have those active false things. Let's like comment those out for now and see if it's working in the really, really simple case.
Yeah.
How do you? Can you just like?
Oh, so we didn't fail earlier. Okay.
Yeah, I don't think we failed earlier. Is this like a comment in this? I'm not really sure.
Let's delete it.
Find out. Error connection refused on my website, dude. That doesn't.
Yeah, I don't see it either, actually.
How come it works for my computer? Are you guys in like a weird? Oh, maybe you can't do it with HTTPS. You need HTTP. My website's like so old and crappy, you guys. It's not even worth it. It's not even worth it. All right, so let's go and look at this new thing. Well, it doesn't work.
Did the comment thing work?
Yeah, I think the comment worked. Did I run it? I think I ran it. So now we have, in our case, select star from simple where id equals 5. Generate index scans. Yeah, generate constraint scans still doesn't get anything. I think we got to go back to the debugger again. Let's just put it here.
Friggin' optimizer.
Yeah, basically. The optimizer.
I thought we had like a language system for this instead of like writing like what the hell is opgen all about?
That thing is all about like these rules. You can make these rules, but the rules don't.
Oh, is that like
for
cost? Is it for costing and stuff?
Nah, the costing is all done with programming too. I was really disillusioned the first time I found this out, by the way. Like there's this file called custom funcs. And in custom funcs, like that's all the actual logic. And the rules are just sort of these like S expression switchers. I mean, the rules are good, but like you still have to write a ton of code. All right, so down here, we're in our contains thing. Okay, so we're now comparing these spans. Oh, right, it's because we made this too stupid. Remember, we were doing a exact comparison. So yeah. We have to make our example like even dumber. It has to be like the world's dumbest example where we make another thing that's like simplest and it's literally only indexing a single value.
Right, equals 3.
Yeah.
42.
And then I think that this will actually work.
It is a partial index.
Yeah, it's super partial. The world's most partial index. Oops, oh, I just forgot. I just didn't update the name of the table. All right. Yes. All right, that's sick.
Okay, so we can like try the overlap stuff.
Yeah.
Now.
Yeah. Let's at least do it at this level. So at this level, instead of comparing for perfect equality, wait a minute. Is a constraint an OR set or an AND set?
Disjunction.
It's a disjunction of conjunctions. So
What is a disjunction again? Is that an R?
disjunction's OR, yeah. So to have the left contain the right, it means that I think at least, like, it means like one of the things on the right has to be within one of the things on the left, right?
Yeah. Oh, well, like it has to completely cover it, no? Like. So if I have shouldn't it completely cover it through the entire like set of left constraints?
Isn't it something like? Isn't it something like A is equal to B or A equals 5 or A equals 10? Wouldn't that be one of these constraints?
I don't understand this example. So like,
sorry. So let's say our partial index is create index on T of A where, and then we did like select star from T where A is equal to 5 or A is equal to 12. Oh yeah, you're right. It needs to be completely.
Yeah. This seems inefficient.
Well, because it's also weird because like theoretically you could decide that you wanted to split this thing up into multiple index scans, but I guess we can just assume that that's not going to happen because that would be like super wild and crazy, right?
What is Postgres? Yeah, I'm like super curious now. What does Postgres do about this? What do I even search up?
In their code base?
Like partial index.
Yeah, something about partial indexing.
So we need complete overlap for the whole thing.
Yeah.
The left hand side spans, they are ordered, however, right?
Yep.
By the start key.
Yeah.
So that's good.
Yeah. So complete overlap, what does it mean exactly? It means that everything on
in the right span should be contained.
Everything on the right should be contained. So we can
right. So I think I have the end keys as well. I need something like start all the start keys and end keys and kind of like jump between them, and then make sure that I'm not missing any gaps.
Yeah. So there is this thing called contains span already that does it in the single case, and it does binary search. And I think in this case, basically, I mean, we could just literally loop over and do this once per thing, right?
Yeah, but then what about if your right hand span like straddles two left-hand spans.
Oh.
Like that's the thing I was worried about.
Oh yeah, you're totally right. So so the example would be like
you need to find like the subset of each right-hand span that overlaps with the left-hand span subset that you're currently working with, and then try the next one if it's not done, and then kind of continue doing that back and forth.
What example? Could you give me an example of like that weird case?
Right. Let's say your partial span is from 3 to 5, and your left-hand side is from 1 to 4, and then 3 to 6, and your left-hand side is 1 to 4, and then 5 to 8, whatever.
Wait, A is greater than 4 and A is less than 7, and the other one is what?
Say 1 to 5, and then 6 to 8.
1 to 5.
Oh, so, the other way around. Actually, sorry. Your partial index is 4 to 7, fine, and then select. Yeah, so we have to try.
I think we need an or here to make it interesting, right?
Yeah.
Or A is greater than 14 and A is less than 17.
Yeah. I mean, you could also just do A is greater than 7 and less than something. So it's kind of like it's a partial index. Even though it's like next to each other, it's still broken up. Like they're two.
Oh.
They're two.
But I think if two things are next to each other, there's some other part of the thing that like automatically merges them earlier.
Oh, okay. I didn't know.
So you're talking about like it would only be bad if this left one was A is greater than 7 or A is greater than or equal to 7. That would be bad.
That, yeah. Yes. And then you'd have to like check your like whatever the constraint below. You'd have to check that it doesn't like straddle two things.
Yeah, I think we can not have to deal with that. I think the very simplest thing we can do that should actually work is just loop. Yeah, exactly. And we'll say C dot contains span. This needs an eval context, dude. This shit drives me crazy. And then this one has to also have an eval context. Eval context is so evil. It should really just somehow be slaughtered. C dot E dot eval context. Okay, nice. And then back in our stuff, we can contain span, eval context, other dot spans dot get of I. So if
you can also like terminate early.
Yeah, like this, no?
By terminate early, I mean you don't have to check all left-hand side spans if you know that you're like behind. Like your end key is smaller than the left-hand side right key, like start key. Like say in your first example, it also was or A is greater than 100. You don't need to check that.
Oh. Wait, but we're checking right-hand sides into left-hand sides. It's like the opposite.
Right. And if you're so other dot spans is left-hand side, right?
No, other dot spans is right-hand side.
Oh, okay. My bad. For each one, constrain. See that contains spans, left-hand side. This one. So we have one. Oh, so C here's the span, the constraint set as a whole.
Yeah.
Okay, contains span. Yeah. Okay. I think this works.
And we can actually get rid of this guy as well. This spans check because I don't think it matters anymore. All right. Run them tests. Boom. Okay. So simplest is working, and simple is also working. Yo.
Nice.
Yo.
That wasn't as bad as I thought it would be.
Yeah, not really so bad at all. And let's make this one an opt as well.
Okay, so like what's missing?
Yeah. So what's broken still is that if the more complicated example is still broken. The one with multiple
Boolean
columns. Yeah, exactly.
Hmm.
But we could call it quits here maybe, because we've done a good thing. We've done a good thing so far. And we've made a lot of progress today. Let's see. Look at all this. Look at all this modified stuff. So yeah, how are you feeling, Irfan? Do you still want to do other stuff? Because we could.
I think I'm good.
You think you're good?
This is a 2-hour long interview. I'll pass.
Yeah. Well, next time I used up a lot
fun.
of time with this, I guess. But next time we should figure out a way to swap the drivership. I agree with you.
Yeah, I actually like let me. So one thing I noticed is like your Twitch stream is like pretty smooth as you're typing things. I don't think that would be the case for me.
Well, let's try it out. Here, why don't you just like do a couple of things?
Do you see my screen now?
Yeah, I've full screened it. You'll see in a second.
Okay. 1 second. You see it?
Yeah.
How bad is my cursor?
It's like all right. It's like pretty good.
It's like. Oh, actually, it's not too bad. Yeah. Okay, that's kind of what I was worried about. That it'd be like janky.
Yeah.
Janky. Okay.
So, Irfan, tell me what you're working on right now.
Well, this is your constraint code.
Yeah,
I'm just looking at it on my side as well.
But like, what were you working on?
What I was working on was, other than this make hack stuff, was this migration infrastructure stuff that we haven't
Oh yeah,
played.
That's right.
So we have the system. Well, like Cockroach needs to kind of like stay up and running. What am I doing? Yeah, we need Cockroach to like stay up and running as we're doing internal migrations, kind of moving stuff that looks one way to another. We're also like serving requests and whatnot. We have this concept called like SQL migrations that I think you might be familiar with.
Vaguely. But let's like talk about a little bit like what's a migration that one would want to do? Why do we even have migrations at all?
So these are a few examples. So like per release, we kind of like add a few new things. We add a bunch of like system tables. That's what SQL migrations typically look like. We're adding columns to existing system tables and whatnot. We're creating new ones. We're adding this jobs progress thing, for example, which is like a progress column, I think, to the jobs table. 1 second. But so essentially, you have a version 19.1 or 19.2 cluster running that, and then you want to roll over into 20.1, and 21.1 code depends on new things existing in your system. So you kind of want to introduce that on the fly at some point. With system tables, what we actually do is something much simpler than that. Whenever, so our let me pull this up. So on startup, the way we kind of migrate clusters today is that you have like a bunch of previous version nodes running in play, and then you slowly introduce one by one into this new thing, and then you run something called set cluster version, and you're only allowed to run the set cluster version this command once you kind of guarantee that all the nodes in the system are a certain version, and then we kind of like are able to transition things because we know that this new binary has the code to kind of deal with this whatever changes we're trying to make.
Right.
And essentially we have this thing now where on Bootstrap, essentially when the first server starts, we do this thing called ensure migrations, and it kind of like chomps through all the different migrations that we've like hard coded in.
Right.
So we have this giant list of migrations here. We kind of like go through them one by one, and we add them up. It kind of blocks. There's only one thing running, and it kind of like blocks on startup, and does all this stuff, and then everything is free to work with essentially. Now the idea is this is fine and good. It kind of like works for SQL systems, like adding system tables and stuff. But we want to do something a bit more complicated. So say we have, say, like take the RAF storage stuff, for example. We have all our RAF stuff sitting in one directory today, and we want to be able to move it over to this other storage directory so we can do some funkier stuff with it. But we also probably want to do it live. We can't do it on startup because there's so much RAF data in the system. By doing it on startup, it would take like a long time to actually boot into the system, and that just leaves room for error. So what we want is something along the lines of the thing that I'm working on now. Essentially something that lets you write code that looks like take every node in the system, run some random code, in this case just act pending version, and then once every node in the system has run some code, you run this top level migration that counts on the fact that all these nodes have like either upgraded to some version or like done some setup.
Right.
And then in this migration itself, it also looks like something like this.
And this is like, it must be like async or something. Like what?
This is it is async. So the way we're thinking about it now is essentially we'll set up a job in the system that gets owned by some component, and you kind of like track that job, and this job will slowly go through all the steps that you need to kind of copy things over back and forth as you need them. And one example is the kind of primitives I think we're looking to provide is like take every range in the system and do something with that range, like lock it down so that like you can do some stuff that requires locking. The RAF storage stuff is one example where you can't really have any other incoming writes right to the RAF data. So you can like lock it down, copy it over, and then unlock it, and then requests kind of like go on as before. Right. Things of that sort. One other example I think like Rohan brought up at some point was like rewriting table descriptors. So we have some of these migrations that run that essentially as requests come in to a specific range, it like version 20.1 code knows that this request is a bit out of date. Yeah. So as I'm processing the request, I'll go ahead and like actually make upgrade my range right there and then. So say I have this old table descriptor format. Anytime I get a new request and I find the old table descriptor format on disk, I'll kind of go ahead and rewrite it, and that's fine. And then kind of going forward, all my code only has to like work with the new table descriptor format. Yeah. But the problem with that is these migrations only happen for the ranges that actually receive requests. So you can very well imagine that there's like some random range that has like not seen that request, like not seen any write activity. Of course. So never goes and upgrades that. So when we cut over to the version after 20.2, we still have to keep code that has to consider the old table descriptor format because, well, you might always have a random range that kind of comes in expecting that, and then it has no idea how to deal with the new format. Yeah. But if you have a primitive, something like take every range in the system and like run some random code, then you can like force it to migrate something. Yeah. And by the way, like none of this is hooked up yet, so this is completely like unconnected code. There's just a bunch of like to-dos that like we're like trying to track up. We have this. We're thinking about this primitive, which is required node. I just learned that we have this node status table in the system. Yeah. I think.
Node status. So that somehow like keeps track of all the available nodes in the cluster.
Yeah. I tried hooking up my terminal to this IDE, but like I don't get the right commands all the time. Oh. Okay. Yeah. So we have something like this for like all the nodes in the system. It kind of like gets tracked somewhere internally, and we might want to use something like this to find out all the other nodes in the system that we can like send RPCs to like run these every node requests. Again, none of those things are hooked up yet, but that's the idea.
Interesting. So what would it take to have to hook it up is the question, I guess.
So there's like one kind of component that I think I would work on next, which is this like service process that would like run on every node. So we essentially we have this like server.go file that every node is running. kind of expose another endpoint here essentially that can handle a few RPCs. That if I send this like migrate request, this every node request with some action, which is not really anything right now, but like a protobuf action that now every node, once you receive it, you know how to like handle it. These migrations are idempotent, so you can like get it again and again, and that's fine. You work about it safely. That's one component. The other component is similar to this, but like I mentioned here, we kind of want this primitive, which is, where is this? Like iterate over every range in the system. We need a way to like issue these requests and send up these migration commands to every range in the system that does one specific thing. I think we have something like that right now that's also still not hooked up. Command migrate. So you can send this roachpb.migrate request. And are you familiar with like what these requests look like?
Vaguely. I mean, this is like basically the KV API gets implemented with these things.
Yeah. So you know how like SQL requests kind of turns into like get, put, delete, whatever. This is essentially just like another kind of request. Right now it's very opaque. It just says migrate, but you would kind of like ask. You'd kind of provide a few arguments with it, which version you want to migrate from and which version to, and each node would store locally on some like small part of its key space about the version it's like most recently seen or like knows about, and only run the migrations that it actually does care about. And then by the time it returns, and this is kind of like the cool part, I think, which is you have these primitives that you can like kind of like talk about where every node's run this code, and now you can like act back to the client essentially that all these migrations have taken place and it's like safe to proceed, and you can queue up future migrations being contingent on like previous migrations. So say I have like a new table descriptor format and then have a new table descriptor format on top of that, I can kind of queue up requests that like, well, this one is dependent on this, so as soon as that one runs, I can like trigger the second one. And things kind of like flow from there.
Yeah, I guess, I mean, isn't it kind of easy to imagine that like the client would die, or like what happens when any of the ranges die, for example, like if the node dies that a range is owned by?
So that is a good question, and that's kind of so we have this like job system that I'm not completely sure about how it works.
I see.
Maybe you know. So we have a way of like resuming jobs, right? Like things.
I see, and everything's idempotent, so it doesn't really matter. Like you can start again, and it won't hurt anything.
And in fact, like during cluster version upgrades, we do require everything to be up when you start off the process, and if anything does fail, you'll kind of like, well, you'd have to like start over essentially. But yeah, everything's idempotent, so everything's safe anyway. By the time like, if you're act as a client, you can assume it's gone through, and then that's fine and good.
This is cool stuff. Makes sense. It seems like sort of tricky. Like to do this at all, you have to know about this extra key space thing that you're talking about too, which is sort of funky. Like
like we're defining those, like that key space. It doesn't exist today either. But yes, so we're kind of like leaning on this other thing that I learned about yesterday called the lease manager. Do you know about this?
No.
Okay, so it's kind of cool. What am I looking at? Right, it's called lease.go. Essentially, you can kind of latch on to one key. You have this acquire lease API, and SQL migrations actually use this, where you specify like a random key, where nobody can acquire lease over that key over like a specific time frame. If you crash, then that's fine. That somebody else can kind of pick it up after you. But this is like a way to like ensure like distributed mutual exclusion, essentially, kind of like etcd locks, but like leases.
That's cool. I didn't realize. This is very nice, honestly.
I know, and this kind of like does the simplest thing, which is it talks to the KV interface, db.transaction, and does like a conditional put or something on some value, and if it's there, well, you're kind of like blocked on it. If not, and then you can also kind of extend your lease by doing the same thing, this db.cput.
Wait, so who all uses this lease manager right now?
It's just SQL migrations, because you kind of want to include actually SQL migrations, and I think jobs as well. uses it to some extent. But this is essentially the thing I think I'm going to be leaning on more than the jobs infrastructure.
Yeah.
Because I think Andrew's going to be rewriting some of the job stuff.
That's actually cool though. Like it's because we have all these other random leasing systems, and it does make me wonder whether we could sort of, get rid of them.
Yeah.
That'd be nice.
Ron is mentioning that jobs uses a different lease manager thing.
Well, jobs, but also like all of those table descriptor leases and schema leases. Like there's all of this stuff, you know. I don't know.
This is something like Andrew was griping about as well, that they kind of like want to like have. Well, like ideally, like this stuff should not be using the KV API as like puts and gets and then doing that. It should be like a first class primitive.
Yeah,
So
I guess that's a good point.
like,
I mean, like puts and
flesh
gets
that
are
out.
first class. I don't know. I mean, it seems fine basically.
No, I mean like leasing should be a first class primitive. Like we could do a lot faster if everything was like folded inside.
Oh, really?
Yeah, I think so.
What's the like double work in this case?
Actually, maybe we can't really do faster. Maybe it's not a performance thing. I think it's just like we've already seen like a bunch of different like lease managers like bubble up in some form or the other. And this is a very thin shim over KV, so might as well kind of pull it in and own it. I think this is all like Andrew. No, I wonder who wrote this.
I don't know.
Alex. Oh, this was a long time ago.
The lease manager has been available but unused.
Yeah, there you go. But yeah, we do have all these like random leasing systems, and we have a pretty like powerful KV layer, so you probably should be using it more.
Yeah, probably.
Generally, so.
Oh, I see. Rohan was saying stuff. Jobs use a different lease manager. Does the same thing. Wow. It's exciting. But I bet like probably migrating between the two systems is probably like a complete pain in the ass because they use like different keys and you'd have to have some way to do it.
No, actually, that's a nice thing because we know exactly the key that each lease manager is like latching on. So
that's true. Well, as long as they use the same mechanism, which is not guaranteed.
They're like close enough.
I see.
I think. But yeah, but the idea is actually to like fold in the SQL migration stuff into this final migration package, so everything kind of uses the same set of primitives that run all this code if like everyone's at a certain version, and then by the time you kind of act back to the client, we have some guarantees that can like talk about going forward, things of that sort. If things fail midway through, well, like you have to like error out. There's no way to like handle it, but yeah.
Yeah. I was gone for a while during the migration talk. Yeah, not making it probably, right?
It's not. Isn't the deadline next week, Monday?
Yeah.
Maybe if I pull off like a heavy weekend, but establish balance.
Press F in the chat for respect to the migration framework of 20.1. You're self-effing. That's not good.
Yeah, and with the Sigma stuff, if it wasn't there, it should have gone in.
Oh yeah.
Maybe.
Well, that stuff is great. I'm excited for that. Very excited for that.
Yeah. I'll bow out now.
You're gonna bounce?
Yeah.
Yes, thank you. Roland for the F. All right, man. Well, this is very successful. I'm glad that actually we tried out this Zoom integration because it works really well.
How does that work? Yeah. I see the video on the stream too.
Yeah, it's like pretty sick, honestly. I didn't realize. Yeah, Hangouts is not this powerful.
Yeah, okay, so I was worried about the lag, and that's why I was trying Hangouts in the morning with myself, and there was like a lot of lag, but I guess Zoom is not as bad. Maybe it's something else.
Yeah. I don't know.
But Zoom does give you this like kind of hover window, which is nice.
Yeah, the hover window. If only I could pin it. That would be next level, but I don't think you can do that. Anyway.
Cool.
Oh, wait. Hold on a second. Wait. What happens? Did you get any notification?
I have remote control access of my screen. Which should I?
Yeah, do it.
Right. There you go. System preferences.
It doesn't work.
1 second. I still have to grant off.
Zoom and Twitch is a lot higher quality than I expected. Yeah, it is really good, honestly. It claims that I'm controlling you.
You are moving my mouse around, yes.
But I don't see
I'm not
it.
sure why. I'm not sure why I give you this access. I don't think I want to.
It's like really, really, really bad. It's like really
But yeah,
bad.
there's a lot of
Oh!
lag.
Oh man, this is so awesome, dude.
How do I undo this? Stop.
I'll turn it off. I'll turn it off. But this is amazing. Wow, 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 wow. That is next level. Oh my gosh. Time to hit that RM minus RF star. Yeah. Wow. Okay. I have a newfound respect for Zoom at this point, to be honest.
Yeah, not bad. We're a corporate company now. You gotta use these webinars.
Yeah.
Webinar tech.
I guess so. All right, man. Well, this was great. Thank you so much for spending time with me and our stream and our future YouTube videos. Say hi to YouTube, Irfan.
Hello. Oh, does this get uploaded?
Oh
as well?
yeah, it's getting uploaded.
Yikes. Okay. I feel like I should have known that before.
No, it's all good. We had a great conversation. Right. I think you could learn a lot, maybe.
Yeah. Optimizer is not all code gen. I learned.
Yeah, Optimizer is not all code gen. I learned. That's gonna be the title of the YouTube video.
Cool.
Okay. Bye, Irfan. All right. Well, it's me again. Just me. I'm going to go to the bathroom, and then I'll be right back, okay? I'm going to give us a special scene to display that I'm gone for a second. It's called this camera. Speak right into the camera. Look at that. I'll be right back, you guys. All right, we back. Okay, boom, hit that transition. So what's happening at this point? At this point, I basically think that we should maybe make a little commit for this stuff that we've done with the partial indexing. And then the question is, do we want to keep messing with this partial index thing or do something completely different? I had an idea for something that I wanted to try out, which was making a little GitHub bot that responded to PRs with some like suggestions and stuff like that. Thing is, I don't actually know how to write JavaScript. And it turns out that the way that you write a GitHub bot is to write JavaScript. It's kind of wild to me. So yeah, I don't know. I might take a look at doing that in a second. But in the meantime, let's go ahead and make a little commit for this guy, even though it's not quite really finished, honestly. First, we got to get rid of this. Hold on a second. There's a couple of things to fix with this current invocation instance of our code. One is that we have pointless empty method. Let's get rid of that. What else is there? Have some random prints. Probably want to get rid of those. Or I thought we did. We just have a pointless import. Why? Oh, I see. It's not a random print. It's a useful, helpful thing. I'm gonna keep that. I guess we could add, probably want to make this a little bit more obvious over here why we're just quitting when we find a partial index generating the full index scan constraint things. Can do that. Basically, we'll say at this point, if we have a partial index, we're not allowed to do a full table scan, full index scan, because no matter what, we'll never be able to satisfy the partial index predicate since we don't have a filter we're looking at. Pressure's on, super strong twitch. What's going on? You missed a lot of things, my friend. You're currently my only viewer. So I appreciate that. I appreciate that a lot. But we had some crazy stuff going on earlier. Zoom calls. You know, you can remote control somebody's computer with Zoom. It's absolutely wild. But in any case, we were sort of just wrapping up this commit here. Just did it for the first time earlier this week. Yeah, what were you streaming? Oh, you weren't streaming. You were Zoom remote controlling somebody's thing. Yeah. The partial index adventure, it's going okay. It's going okay. We've made a lot of progress, truthfully. But I don't think that we can finish it today. We're gonna have to have a part 5. And yeah, we'll just like do a thing here. So we'll say teach the optimizer to generate constrained scans, or teach the optimizer about partial indexes during scan generation, something like that. And we also have this test that we added, so we can stick that in the commit as well. And then go like this. I think actually, let's call it a day. I think we've done our bit earlier on, and now I think that I'm a bit ready to stop. But thanks a lot for watching, especially if you're watching this on YouTube, where it's gonna be. And you know, I'll see you guys next time, and hopefully we'll finish it up, finish the partial indexes, and get it into the database. Make people have better data access patterns. It's the dream. But GG. Thanks, Roland. Thanks, Super Strong. And let's call it. Actually, wait. Let's do that thing where we... Let's just do that thing where we leave. Okay, see you guys. Thanks a lot.